Okay, I think we're ready to begin, and I think we'll launch in maybe to Lee Coates, as he probably has something to show there. He has a big beaming face, and looks like he's ready to show something here that's interesting. What do we got here now? The plasma puck. Let's say that properly. Plasma puck. Try that 10 times in a row. Plasma puck. Plasma puck. Okay, we won't go there. All
I
right.
thought
So what do you?
I think that'd
Okay.
be a good thing to call it for us Canadians.
Yeah. Well, okay.
So,
Plasma puck. Wait a minute. I gotta stop the beeping here. I just gotta do one of my settings on the chime effect. There. Thank you. Now I can hear properly. Um, tell me now. What do you got there? The plasma puck. This is good. What a Canadian idea. I could. It needs to be a little smaller, like hockey size, but I don't even know what it does yet. But it's already a good
this
idea.
this is a car mag grab about I don't know, 4 or 5 weeks ago. Armin was talking about this single coil car mag grav. So this is
Okay.
what this is a single coil car mag grav. So I'm reporting on a failure this week.
A
Uh,
failure.
yeah, I
Okay.
made three of these.
Hmm.
Um, and then I cut the ends of the wires off and measured the resistance on the through the copper on the wires. Um, and This one had 7 mega ohms resistance. The other two had about 16 kilo ohms. Uh, I said, well, maybe this one will work. So I went to put it in a gal's car here last Friday, and of course, as soon as I hooked it to the battery, it sparked like crazy. 7 mega ohms, I guess, is still not enough resistance. You need an infinite resistance, I guess. So I didn't put it in because
Did
it
you
drained the battery.
did you measure the inner part of the wire, like the bare copper, or did you measure on
That's
the outside nano coated part of the wire?
the nano coated part is infinite. Okay, it just
Right.
gives me an overload on my meter. So I was measuring the inside copper wire because
Right.
I I didn't want to I didn't want to drain
And that would be
the
the
battery. So
between what the inner coil and outer coil. Would that be the positive and negative where they're attached, or how do you have them
yeah, that's
hooked
that's
up?
the between the red and black. That's the grav in and the mag out.
Right.
So so positive negative. Yeah.
So something was touching matter to matter somewhere along the line, I guess, to
Well,
create such a. You
yeah.
would
Well,
think.
on the two of them that were just 16 kilo ohms, yeah, there's something.
Did you try those ones, plugging them in as well, or just the mega
I
ohm one?
didn't try them with a car. I just rejected those. But this one with a 7 mega ohm, I said, well, maybe it'll work. But as soon
You
as I
would
saw the
think.
sparking when I hooked it up to the battery, I says, no, I'm not gonna put this in that gal's car. She'll have a dead battery by morning.
Yeah, that wouldn't be good. It would probably
So
start melting wires because usually if you hook directly to the battery is not a good thing. It should go through a circuit breaker. Of course, the circuit breaker or fuse would tend to interfere with the plasmatic process that's going on perhaps as well. So there's that
so anyway,
consideration.
I'm going to reject this design and go back to the two coil design, which seems to be working out good. So
Yeah, keep those suckers separated. I think that's a good idea. I
yeah,
mean,
no problem with those.
maybe it should be just a very small gap between them. That's another consideration, but it should be a
Yeah,
gap of some sort, I guess, or maybe
yeah,
an intermediary ball or some sort of go between the two coils is interesting as well. Something
yeah.
that.
I cut the the caps down to
Hmm.
well, there's one to 1 and 3/16, and you can see that the coil in the center is well. This one's about a quarter inch below. Usually they're about an eighth inch below. So there's when the
Hmm.
two halves go together, there's about an eighth inch gap in there or something.
Right. Yep.
Eighth inch to a
Well, that's
say a
about as
quarter inch to 3/8 gap is sort of what I'm shooting for.
right. That's probably about as
So
close as you want there to allow for
yeah.
expansion and contraction and
So
whatnot. And
anyway, so I that way I'm absolutely sure that they won't short out the battery. so so
really cool. Thank you, Lee. Any more to report there on that end?
That's it for the car mag grabs. If there's any questions, and I was doing some more ice things.
Okay.
Well, I'd just like to bring up a lady I'm working with, Jackie, down in California. She's building these units, and Lee, I'm trying to get her and you together. Asked her to come in tonight, but I don't see her in the list. Her latest one installed it in a, what was it, a 99 Saab. Went from roughly 27 to about 57 miles per gallon.
Wow.
She's been having really good results with the basic simple design that I taught Dave to do, and the same one I showed you, the original.
Yep.
These seem to be working really good. We don't know where the failures are yet, why some of them work, some of them don't. I got a feeling it has to do with the car computers, because we know the car manufacturers, they're not allowed to create high mileage vehicles, so they'll probably, some of them may very well put in the software that if the mileage goes above a certain point, that it just starts opening injectors and you don't get high mileage at all.
I never thought of that.
It's possible because they are heavily into the defeat mechanisms to give you more power rather than better emissions. They don't really care about the emissions once they pass the emissions at the testing lab, which is only a 1 out of 1 million cars or whatever gets tested. After that, all bets are off. And as long as they produce good power, then that's what the computer's geared up for under real life circumstances. This is what we're finding out is basically they've been cheating by bypassing the emissions testing while they're emissions testing. You have a thing that if the steering wheel's not being moved and the accelerator's accelerating, then that means you're doing emissions testing. So it goes into a default mode that gives really good emissions, but not as much horsepower.
Yeah, the ones we're having the best success on are diesels and the older cars without the fancy computers.
Oh yeah.
So I got a feeling there's something in the new car computers that's going to get in the way. It's going to cause us some issues.
Okay, I've got results so far. I've had about 6 or 7 people getting about 30% savings. I have had one person with 0, well, 2 people with 0, and my truck's only getting about 5-10%. But I don't drive very much, so it's hard to regulate it or test.
Another thing she noticed, she had a unit sitting in the house, not in a car, but hooked up to a car battery in the house. And a friend of hers was over, who was standing next to it, and his feet and lower legs got all really hot. And he's bent over and he's reaching down and he's touching his legs, and she's asking him, well, what are you doing? What are you doing? He goes, it's warm. And so he walks away and his feet get cold, and he comes back and they warm back up again. So we got there is something really interesting going on here. And I definitely we need to pursue this a little farther, because these reactors are doing extra things that we didn't expect. And the more we play with them, the more we'll find out, I guess.
Was that one, was he close to the reactor when this heat thing effect was happening, or was it on the opposite side of the car, or how was that?
Well, no, it was in the house.
It was in the house. Sorry.
Sitting on the floor with hooked up to a car battery, because she was doing a test if it would rejuvenate a battery, and he was just next to it. I don't know exactly how far. I assume probably a foot or 2 away from it, and he noticed his feet and legs got hot.
Interesting. Okay. Can't hear you, Lee.
You're muted, Lee.
Your mic's off.
Either that or you pulled the plug out.
Your mic's open here on the participants list, but we're not hearing you.
Nope.
Yeah, it seems to be
something there. Hello?
Testing.
Yeah, I can hear you there now.
Huh. Okay. Well, I just unplugged it and plugged it back in again. Yeah, I'd like to get together with that gal, because it'd be nice to compare the the fine details, what kind of GANTs and all that kind of stuff she's using. And
she's one of the distributors, and I brought her into the Reactor group, so she's in the PRG Skype room. And I sent her a note earlier on and let her know that we're live today, and I hope she'll come in.
Okay.
Okay, well, that'll be interesting. Thanks. Okay. Do you want to go on to something else there, Lee? Is there any other questions first about that setup and about that topic? Let's say. Going once, going twice. Okay. We can move on to another. I see Vivek has a video up there, but Lee, do you have something else you wanted to discuss?
I had some more ice pictures to
Right.
show
Ice
if
is
I can
nice.
find.
Saw a picture yesterday of a soap bubble freezing, which was quite interesting.
Mm-hmm. I've seen it too.
It's on Facebook, I guess, pretty prevalent now. It's just beautiful the way it freezes. I thought we could do that with a Gans bubble of some sort.
Okay, so
yeah, we see it there
well,
now.
after seeing the picture that I don't know who had it, that guy, last week they showed a picture of a bottle that was on Facebook, I think. So I decided to put the health pen in a tall juice bottle here. And the interesting thing, this is the core of the pen that we're looking at the results on right now. It's the one with the 2 coils and the 3 and the center pin. And so we got 3. Can't see the third one that's sort of wrapped around there, but there's 3 pins coming down out of it. And you can see this the circular swirls in the ice right now in that bottle. And
yeah,
it was interesting. You got swirls going clockwise and swirls going anti-clockwise in it, and it's not this one isn't fully frozen yet. This is just sort of on the outside. So I thought that was interesting.
The pen's in the middle of that bottle, is it?
The pen's right at the top of the bottle.
Okay.
Okay. Yeah. So that was sort of interesting. That's sort of what you'd expect, I guess, is a magnetic and a gravitational field would swirl opposite directions. So
now these swirls, they're not just bubbles we're looking at. It's actually more like stress or like layers in the water itself.
It's not cracks, so it's probably if it's very fine bubbles, I guess you'd say, not extremely fine ones.
And what kind of this was
just a stress part in the ice or something. It's but it's not a crack in the ice. It's it's actually
sort of the way frost forms on a window and so on. Is this tap water you used or
no? This is distilled water.
Okay.
Okay.
Thank you.
Then after it froze solid, that was a pen that just had the center pin and the bottom and top coils cut off. So, but you can see how the shape of the bottle sort of defines the field. That's what the interesting thing I got out of this is you put it in an oddball shaped bottle, you get an oddball shaped field to a certain extent. So if to do a real valid ice test, I guess you got to I haven't done it yet, but put it in a great big bucket of water and right in the middle and see what happens. So, and this was.
There's quite a science actually to the whole thing of freezing water. For example, the bartenders know a trick about how to make ice cubes that are clear, completely clear, without any bubbles in them, without any stress cracks and bubbles, and just clear ice cubes, which are a real treat apparently for people with cocktails and whatnot. So usually they have a process. Either they boil off the water, or they use a prepared water that's already been boiled or somehow degassed. So anyway, go ahead.
Okay, this was the pen which had the 2 prongs cut off the bottom. So it's just the 2 coils with the loops on top. And got not such a big ball at the top like the other one. It's fairly narrow going down the middle.
Yeah.
Again, you can see some of that spiraling going around there a little bit. It's strange how it balls up down the bottom. Okay, and this is the how I'm making my pens basically with the pins on the bottom and the return loops on top.
Mm-hmm.
And this one you can see a little bit of a bigger. Well, there's a stronger field. It's wider at the top, and it's about the same narrowness going down the bottom, and you got the ball at the bottom again. So, but anyway, it seems to be following the shape of the bottle. So somehow the plastic bottle is channeling the plasma energy. But I think that one with the two pins at the bottom looks like it's given a stronger field there. So, which is what I expected. But
did the other one have the cross fields in the middle there that you were showing in the last? Like, I don't see the cross fields in this shot, for example. You can see them in that one. You see them a bit there, maybe? Not there?
yeah, you can see them in
See
that
'em
one,
there?
definitely. That's the one without the pins in the bottom.
Without the pins, okay.
Yeah, that was that one. This one here, you can't really see them in that one either. That was one without the pins and without the return on top.
That's what I was wondering, if it was the one without the pins that showed without the. Some of it I see now is part of the structure of the railing outside, and light and so on is reflecting in the bottle somewhat there.
Yeah, so this is the production model with the I don't see the swirling in that one, but it was strange that it gave you that swirling effect. In fact, all three of them had that swirling effect when they were partially frozen before they had this bubbles in the center.
Right, which might be a better indicator. Actually, it might be a better way to do it.
Was interesting. So. Anyway, that's back to the start again.
That one we can see the double crossings quite good there. It seems with the, or I guess that's a wire in behind. It's hard to tell sometimes. Okay, interesting. Thank you, Lee. That's definitely, we need to be able to standardize that test somehow. It seems like it's nice having the standard. What do you call it? The tubes you have there, the
test tube?
Yeah, they're test tubes, but they're special ones for centrifuge tubes. And if we all had the same size centrifuge tubes, for example, and had various standardized health pens, and then a standard container that we're freezing in, and a standard water at a standard pressure and temperature and pH and stuff like that. Especially this degassing, whether the water is degassed or not, makes a huge difference. So anyway, what do you have there? There's we're seeing a black screen on top here.
What are you seeing?
There's a black screen on top of your Windows photo viewer. So we're not able to see the image underneath. Maybe you have to reshare again.
Okay.
Okay, I see an image there now of the bottle. I see you now.
Let's do the screen share again.
Yeah, Tom Salas on Facebook. He reported today that he's done so many of these tests now that his whole fridge is plasmatic, and it doesn't matter whether he puts a nano-materials in his fridge or not. He gets the fields in whatever he freezes.
Those other bottles I did, they were outside on the back porch, by the way. And this tub, I decided I needed a bigger tub and do this distilled water tests with the Carmag Rev. So while this was freezing, this block of ice was crystal clear with no cracks in it. Okay. And then I sort of wiggled it. I could see an air bubble down inside, and it wasn't frozen in the middle, but it was outside. Yeah, for 4 days. It should have been frozen solid. And then on the last day, it warmed up outside to about 4 degrees. But I mean, that wouldn't have been enough to melt all this ice. And the strange thing is, it went from crystal clear ice to ice with all these bubbles in it. And I have no idea why
What do you
it would
mean?
change.
How quick did that happen? You mean like overnight or something, or
Well, for 3 days, the ice was crystal clear, okay?
right? Yeah.
And then on the fourth day, I said, well, I better haul this thing in and thaw it out and see what it looks like. And I discovered that the ice had turned with all these bubbles in it. And then,
Wow.
and when I took it inside, I've discovered there's, great big hollow in the middle that wasn't frozen. So, and it was out in the back porch in the sunshine. So maybe I'll have to try it out in the front porch without the sunshine. Maybe the sun was having an effect on heating the deck boards below it or something. But it was, it was minus 20 to minus 10 for a couple of days, and then it warmed up. So it should have been frozen solid at those temperatures. But
yeah, you would think. Well, the maggrav maybe was producing some self-warming effect in there.
Well, it's possible. The two wires on the maggrav are twisted together here, so the plasma energy would have been flowing through it. But
they're not hooked up to anything, right? They weren't hooked up to.
No, they're just twisted together.
Right.
So.
Well, that's interesting. I mean, what if you could maintain a 10 or 20 degree difference just with a maggrav, and it would prevent water from freezing to have it in there? That's kind of interesting in itself. There should be some way to take advantage of that gradient,
Yeah, so I think I'm going to fill it up again and put it out in the front porch where the sun can't get out and see what happens. We report back next week what happens.
Put a second one on the other side of the porch. Keep them 8-10 feet apart if you can, with the same amount of water, just to eliminate the possibility that it's just not freezing fast enough.
Yeah, could do. So anyway,
interesting. Okay,
that's it for that.
It's very interesting that the bubbles formed in the ice after the fact.
Yeah, that's kind of a mind-boggler, eh?
I can't explain it unless it's something to do with the sun warming it up and doing something. I don't know.
Well, you'd think if the void was formed in the ice after the ice was created, that it would fracture that crystalline structure and it would be full of all kinds of little cracks. But the other picture you showed, it looked really homogeneous.
That's what I can't. That's why I'm scratching my head, because it was just crystal clear ice with no bubbles in it. Distilled water. And then all of a sudden, 4 days later, I got all these little bubbles. So.
Well, that's where you needed to have one of those time-lapse cameras, watching it minute by minute, and when the little pixie comes in through during the night and starts dusting bubbles into the mixture, you'll get a picture of it, right?
They look like lots and lots of planets.
Yeah, it looked very spectacular initially.
Yeah.
It's not just little bubbles, but it seems like each bubble has kind of a little bubble on it or something. They're not totally round. They're like a bubble on a bubble, aren't they?
Unless it's a drop of water in the middle of it, I'm not sure.
Yeah, and they don't look all that random either. There is a bit of a pattern there.
Yeah.
Yep. It looks actually like what I see in my CO2 kit. There's quite a lot of bubbles that occur in my CO2 kit, and I think because of the freezing action of the water, the bubbles were captured in place.
Well, that's where I scratched my head though. For the first 2 days, the ice was crystal clear and had no bubbles in it whatsoever, and then all of a sudden these bubbles formed. So how'd you get bubbles in this crystal clear ice? I don't know. Strange.
Maybe the heat of the sun did something.
Well, that's the only thing I can think of. But again, how do you get a gas bubble inside a solid material?
Oh, it's just amazing. I love it. I love
Yeah,
it.
So,
like it makes sense if there's already gas mixed in with the water, which is the case normally, which is the bubbles that form when we let it sit in a container. But if they're already dissolved in the ice, then they should be just the way it is in the ice, and not like we see bubbles in the tests we do with the health pens and so on. There's different bubble shapes. You can see their path through the ice and whatnot. But in this case, where'd they come from? It's a bit of a mystery, all right.
anyway,
Perhaps we are looking at a plasma skin. I mean, that's kind of what I'm the impression that I'm getting looking at this photo.
Mm.
That this may be some sort of a plasmatic skin, like the Coulomb barrier, for example.
Oh, like this is a galaxy on its own. You could see it in terms of planets and stars, and it's got a definite
Yeah.
boundary that contains it. So the
Yeah.
conditions were right for that galaxy to form.
Yeah, so you have the universe, which is that block of ice, and then in it you have millions of galaxies, and within each galaxy you have different interactions of central suns and planets. That's kind of what I think is going on here.
Yeah, I guess we're kind of assuming that the spheres that we're looking at are hollows, are voids within the ice. They may not be. It may only be like just as Vivek says, just a skin that's still solid within inside it.
it could be a water bubble. It's liquid water.
Certainly.
Yeah. Okay. Well, I'm gonna do this on the front porch for the sun can't get out, and see what happens there. I guess.
Yeah, definitely needs a bit more testing. That's great fun.
Anyway.
Do you have any time-lapse camera kind of deal that you could set up maybe?
No, I don't. I'll
Like
have
the
to
new
just
iPhones.
take pictures of it every once in a while.
The new iPhones can do that. I've noticed they have a new setting for the camera application.
Yeah, if you've got the ability to move a computer close to it, there's time-lapse software you can get for your webcam.
Yeah, I guess most computers aren't that happy running at 10 degrees or 10 below freezing or something.
Yeah,
I'm not sure what the lower limits of a computer are.
Get an extension USB cable for my camera. Anyway.
Yeah. All right.
That's
Good
it.
stuff. Thanks. Any more questions for Lee on that?
It would be nice to explore the ice a bit, cut it, and maybe check out these bubbles, see if you can maybe see something special about it. I don't know, my idea was, is it mostly on the surface, or is it really right inside the ice too?
It's right inside the ice, right from top to bottom. Well, all sides.
That's very, that's nice actually.
Have some of the bubbles like moved through, like the way you see sometimes with the health pen bubbles, or are they all locked in place as more or less a sphere?
Well, they were all locked and placed and sort of evenly distributed in the frozen part of the ice.
But as spheres rather than as a tube, like the bubble didn't move through the ice; it just froze in the ice, right? Like sometimes you see little tubes coming from the frozen pens. You'll see a different.
No, it was a sphere, and it formed inside the clear ice somehow.
Yeah, got it. So. Cool. All right. Well, expect the lab report on that for next week, I suppose.
Okay.
There's a guy someone called Seahorses that's writing up about water splitting in the group chat. You might want to read that. It's pretty interesting. Or do you want me to? Or him?
Water splitting from Wikipedia from Seahorses here. It says apparently there's a diagram of the chemical equation of the electrolysis of water, a form of water splitting. Water splitting is a general term for a chemical reaction in which water is separated into oxygen and hydrogen. Efficient and economical water splitting would be a key technological component of a hydrogen economy. Various techniques for water splitting have been used, etc. Photosynthesis, water splitting donates electrons to... Yeah, although we're not talking about water splitting in this case, we're just talking about air in the water, which is different phenomenon. Because there's no electrolysis going on in this, there's no electrical splitting of water into hydrogen and oxygen in this case. It's just the mixed air, which is mostly nitrogen and oxygen and a little bit of argon and a few other trace elements. That's
Maybe
what gets mixed in with the water.
I thought maybe the plasma was splitting. There's like, ooh. Anyway. Sorry.
Well, there is a possibility that that could occur, in which case you could try using a lighter or one of those barbecue lighter things and see if any of the bubbles pop in that are in the ice.
So that means that the hydrogen, the bubble would be hydrogen little bubbles.
Right. Yeah.
So that.
Wow.
Or if they were hydroxy, hydrogen, and oxygen together, then you'd have a nice pop instead of just a little pop. Either way, they should pop. If you melt the ice with a torch, for example, it should go pop, 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 pop if there is any hydrogen there.
Gee, I'm going to have fun this week.
Yeah, do a video, please. Lee with his big, propane torch. Melt it down on an open fire or something. Hey, wouldn't that be cool to have ice cubes that pop when you throw them on a campfire or something?
You might get liftoff.
You finish your drink and you throw your ice cubes on the fire and they go pop, 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 pop. And hydrogen, gives off energy. You could fuel your car with ice cubes that way after you have a drink. Well, there's a winner. There's a product for you that will liven up people's lives, You drink and drive. I had to, officer. I had no fuel. I had to drink my drink and put it in the gas tank. Rick told me to do it. Yeah, I can see it now.
I learned that.
Rick told me to do it, officer. No, I don't recommend drinking and driving. I do recommend some sort of new fuel for your vehicle if it has an existing, if it's using the defective fuels that we have existing now, which I've come to the conclusion that basically all fuels are defective. It's kind of a strange idea, but I think it's true that all fuels are defective. They're a defective product, and no matter how well you burn them, they end up with byproducts that hurt people and kill people. What a stupid idea. I think if someone come up with the idea of petrochemical fuels today, after we hadn't used them for the last 100 years with the knowledge we have today, and they go, well, I've got this great new product that if we use it, it only kills 5 million people a year, but it gives everybody the ability to drive around a little faster. Okay, we would probably go, don't think so. It seems like a lot of people that get bumped off. It's a bit of a side what do you call it?
Effect.
Side
effect of pharmaceutical drugs. It's one of the side effects is a little critical there.
Pricey.
But we've become so used to it. We're kind of like the frog that you can put in water when it's cold and put it on a stove and boil the frog literally, and he just sits there and gets used to the water getting warmer and warmer and warmer, and they don't have any judgment as to what the water temperature is, and apparently the frog won't even try to jump out, and it'll just sit there until the water's too hot, so on. That's one of those science experiments they used to do apparently in the brutal 40s and 50s. That's 1940s and 50s for those who were listening a century or two ahead of time here.
Rick, sorry.
Yeah, go ahead.
Please, I have another meeting to run off to.
Okay,
so
let's
just like
spotlight your video here and have a look here. Just a second, get that up. Sorry, I didn't mean to hog your space. I know you were waiting there with your video. Why? What have you got here? What's it hooked up to?
Okay, this is a very quick update on what I showed a few weeks earlier. This is the give and take MagRev system that John and I have conceived based off of the car MagRev system, but this is working with AC. Now, when we last saw it on the Plasma Reactor group, this system was hooked up as the load on a faulty MagRev's unit. So the idea was that we are trying to use plasma to rehabilitate the faulty unit and bring it back to working spec. Now, the only issue with that is that, although there was flow to this setup, there was no flow through. So that was one of the things that we decided to remedy. And as you can see, there's two sets of wires now, in each box. So one side of this setup is connected to the wall socket, and the other side is connected to a power strip. So let me just pick up this, and I can show you. So there's the wall socket right over there. So from the wall socket, we have connections over here, kind of like what Armand showed in the give and take system. So one of the coils, actually one set of the coils are wired in backwards, and the other set is wired in forwards. So this then connects to a power strip, which is right over here, and the faulty MagRevs is connected as a load on that power strip. And my computer and peripherals, as you can see over here in this power strip, is connected as a load on the faulty MagRevs. So the idea that we have over here is that we want to put the faulty MagRevs behind for a plasmatic source, and the plasmatic source being this. So whatever's on this side of the box sees fully plasmatic flow, and we are looking to rehabilitate the MagRevs unit in that way, the faulty MagRevs unit. Now, at this time, I cannot give you any data on what exactly is happening, because this configuration just went into effect just under a week ago. I'm taking daily electric meter readings, and something interesting is happening, but I'm going to save that for now and come back in probably another 3 to 4 weeks time and give an update on that. So that's what I wanted to show. You're muted, Rick.
Thank you. Yeah. I was just saying that's a pretty big tease that you just teased us with, but that's okay. Well, that's a pretty good idea there. So, rehab. I like that term, rehabilitating a MagRev. It's great. It's kind of like you, naughty MagRev. We'll let you. We'll have to put you in MagRev rehabilitation school for a bit here, and you'll have to do rehab. And they'll come out all straightened out and go through life the way it's supposed to and be of service. Because if you're not being of service, then what are you doing?
The other thing that you mentioned about the tease, unfortunately or fortunately, this is a tease to me as well, because I have no idea what to expect. I mean, we are hoping for a very good result, a positive result, but I wouldn't know until I have a trend in the electric meter readings, taken over a period of time. So, I'm being teased here as well, and it's quite excruciating, but it's a necessary part of the process, unfortunately. Unfortunately.
Yep, sometimes the experiments take quite a bit of time with this process, and that's just the way it goes. As with the processes inside of ourselves, the changes that occur through some of the things we do and interactions we have and so on. It takes time to allow the effects to take place.
Yep, definitely. So that's all I have for today. Thank you very much for your time, for giving me the time as well. I've got to run off now.
Okay, thank you very much. Bye for now.
Thank you. Bye-bye.
Okay, let's get spotlighted up here and back up again. There we are. All right. Well, what do people think about that? Any comments, questions? Otherwise, okay. Well, I can make a comment about Seahorse's comment here, because he brought up water splitting and so on. And he had a comment before that about division of water as it does in picoseconds or less when in a good environment. Well, that's actually true, and I shouldn't have jumped to conclusions in a way there, in that there is an actual ionization of water that occurs, which is a splitting, and that is natural within virtually, as far as I know, as far as the research that I've seen,
Every 24 hours?
in any water. Doesn't matter whether it's ocean water or fresh water or water in your glass, water in a container or whatever. But yeah, around every, I think it was 20 hours, roughly every 20 hours, every water molecule undergoes
Collapse.
a spontaneous ionization. Not a collapse, no,
It's not a
an
collapse?
ionization where you have a separation of the hydrogen and the one hydrogen, and you have the oxygen and the other hydrogen. So there's a splitting of the actual molecule, producing more or less an H plus and OH minus components. But all that happens in a picosecond, and it slams back together again. And it all happens so quickly that it's known as the fastest chemical reaction that they know of. And it's different than the implosion, like you're talking about. We were talking about before, like sonoluminescence bubbles imploding or other types of implosion. This is a little different. This is just ionization. You have the two components of the water just separate and provide the actual. If you could capture that hydrogen, you'd have an atomic hydrogen there. But because it's in water and because it's so attracted to that other OH over here, basically they slam back together again as soon as they separate. But why do they separate, one might ask? What happens, and what's so special about water that suddenly this bond, which is so tight, it's so tight that even when you heat up water and make steam, it doesn't separate that bond. You're not making hydrogen and oxygen then. And when you make steam, it's still H2O bonded together. It's just liberated from its friends and it's able to have more elbow room, but it's still H2O. It's only when you use electrical force like electrolysis or other forms that you can create the hydrogen and oxygen bubbles in the separate electrodes and so on. But this is different. This is like spontaneous ionization of water. It's in Wikipedia somewhere there too, in water. Ionization of water, I think, is under. And it's actually a very strange phenomenon when you think about it, because it takes so much energy to break this oxygen and hydrogen in the water. They're very tightly bound together in a certain angle and so on, and that's what gives water all of its structure. So what happens is, in the water, as in the air and in the environment, in everything, there are waves. There are various small, beyond nanoscale waves that are interacting, energy fields and waves, plasmatic structures, you could say, plasmas. So these plasmas interact and create waves and different interacting waves. So you'll have say you have a wave like this and another wave like this. Well, they can combine together to give a big wave like this. Every so often, they'll just hit the right angle and the right waves, and they'll interface with each other just right and provide a really big wave. Well, that water molecule that's sitting there where that really big wave hits, a really strong wave, will temporarily separate because of that pulse, of that strength of that wave, that random wave, and poof, separate, come back together as if nothing happened. And in fact, scientists haven't been able to even measure or figure that out, that this is happening until recently. It's an unknown phenomenon of water that it's self-ionizing. What a concept. Here we are trying to make an ionized plasma. We've been trying for 4 years to make an ionized plasma at the center core of our, the free plasma, this center core of our reactors, right back from Mr. Keshe explaining to us about how to make the different layers of gases and to make that ionized hydrogen core in the center and so on. And you work with that and create energy and new materials and so on. Here we have water doing it everywhere all the time. I think it's ludicrous that that water is going ahead and doing it, and we've only just recently, we scientists only recently have been able to even measure in the picosecond range, because it's so quick of a reaction that, and so small of amount of energy with one little tiny molecule. Thank you for that correct term. Good to know you're on the ball there. And this tiny little molecule, because all the other molecules around it won't necessarily get affected by that peak wave. It's only hitting one molecule at a time, but it will hit enough that every molecule of water every 20 hours or so undergoes this spontaneous liberation. And I think that's pretty cool. And what if we could contain that in a way? What if we could harness that? For example, what if we had a container of water and leaking a bit. This one actually has a number of bubbles in it now. We're talking about bubbles. You can see them formed on the outside there as well as a big bubble inside. And it's also leaking for some reason here. Anyway, what if we were able to, what if these bubbles represented the spontaneous ionization of the water molecules in there? Well, what if we were able to harness those? And for example, when this is spinning, especially when it's spinning sideways, all the bubbles go toward the center, the very center of the globe. So if we had this spinning, and what if when the ionization of the self-ionization of the water occurred and this hydrogen was momentarily liberated, what if we were able through the spinning process, what if it, due to the gravitational forces of the spinning, under 1,000 G forces, that forces that hydrogen to just shoot up right toward the middle, because the buoyancy wants to separate it immediately from its environment, and it wants to go up. Well, up to it is the center when this is rotating. Especially sideways, it creates that tube in the middle of the lightness factor. The levity is all in the center of this. And so you have that bubble of next to nothingness in the middle. That would be what would attract all those liberated hydrogen, atomic hydrogens from the splitting, the actual splitting of the water. Otherwise, in just water sitting there without it rotating, it's there's no gradient, so the hydrogen might try to rise toward the top, but it would be instantly captured by the hydroxide or OH minus part of it and form the water molecule again, the H2O. So maybe by spinning at a certain RPM would be an enabling factor to capture that self-ionization of water and capture those those hydrogens, atomic hydrogen, just a single hydrogen rather than a H2, and hopefully to capture just the atomic hydrogens in that little microbubble in the middle. So it doesn't have to be a big, huge tube. It's going to be like these liberated hydrogens. There'll be so few, but they'll be very special at the same time. They'll be, like they say, atomic hydrogen, which is the next step to being able to use the hydrogen in a fusion reaction, which occurs with sonoluminescence or other means with that bubble in the middle. So a number of people are getting into sonoluminescence now as a idea to work with. I think it might be important. I've got a tweeter arriving shortly. It's a little a tweeter is a high frequency stereo speaker, and it's a small high frequency. It goes up to 25,000 hertz, 25 kilohertz, and it's 300 watts, so it should be adequate to blow the eardrums out of my neighbors and myself and anything in the vicinity. I have to put it in a special soundproof
But usually you
box.
need two, no?
Not necessarily, because two is nice. You can focus things like in the air. You can use ultrasonics of 2 or 3 to actually levitate objects in the air with ultrasonics. But with and you can put a transducer and glue it on here, another transducer and glue it on here, and have them work in opposite, and you have the waves interacting in the middle to produce that void. Or you can just shake the whole container, because the container itself has a resonant frequency. When you hit that resonant frequency of, say, the liter of water in this container, then that means the whole water and container will resonate. And when it resonates, all the pressure waves go toward the center, and it focuses and produces that voidness in the center when everything, focuses on there. And then if you have that voidness, you have the possibility of collapsing and expanding that voidness. And that's what you want for sonoluminescence. It's basically a collapsing and expanding bubble that every time it collapses, it gives off light. So it gives off light, expands, gives off light, expands, and so on. And it happens in picoseconds, so it's many billions of times a second, basically, and it looks like a continuous glow to us. And a continuous plasma, a continuous fusion reaction is what's possible. They've measured 4 times, they've actually measured 4 times the surface temperature of the sun in a star in the jar, they call it, or a sonoluminescent bubble that they've created. Tiny little micro bubbles, smaller even than these bubbles on, smaller even than the bubbles on here. It'd be in the nano scale, but enough that you can see the glow even in the daylight. And I think that is a beginning, possibly, for a plasma, creating a free plasma inside the plasma of this water. We call, water is sometimes called plasma water or GANS water. We call it plasma water. Why not use GANS and an actual ionized plasma core at the center of this? With fusion, they say that, and in theory and in practice, that the temperatures go up into millions of degrees with this sonoluminescent bubble in the middle. If that's true, that's enough to create fusion in that nanoscale. And if you have fusion with the hydrogen, then maybe we can learn to control it, to have the GANS plasma on the outside and the hydrogen plasma at the center core, and then we start adding hydrogens together, and you create helium, you create other gases, you create other materials from the fusion of hydrogen with other heavier stuff, basically, and create the next isotopes and next materials right in the center core of a spinning globe of water. That's my theory and idea and concept and what I'd like to pursue with that. And not just with sonoluminescence, but that's just the beginning to tease the plasma into shape. I hope to do it without using sonoluminescence, maybe with vibration and with some voltage as well, depending. Hopefully just low voltage, but whatever will do. Start with high voltage and turn it down from there, because I want to generate a free plasma in the center of this structure. That's my goal. Okay, there's my little wrap. Any comments, questions, ideas on that? Any new information on sonoluminescence that anybody can...
Yeah, hi Rick, this is Mario.
Hi, Mario.
I actually, it was Heather Bryant sent me a link to YouTube or whatever. It's a website where there was a fella who had done what I was saying I wanted to try to do, and I didn't know how to go about it. He seemed to have all the right background and everything, but I don't think he knows anything about Mr. Keshe or Keshe technology. But what he did was he came up with a method to translate the periodic table of elements into frequencies, musical tones. And he starts with an arbitrary tuning, which he chooses A, which is the standard tuning at 440, but it's totally arbitrary. And he uses the 7 octaves of a keyboard. So you have from A1 up to A7. And then he finds the frequency of A. I can't hear you, Rick. I think you're muted. I've actually
Going to mention that, yeah, I think you started with hydrogen as I think in the 7th probably, at 3450 or something like that
it's
frequency.
520. I'm looking at it here. I've got it right up here.
Right.
And divide, if you call that the neutron, it divides. But he finds a
Well,
very
he calls it the proton, though. Wouldn't it be the hydrogen?
He's not dealing with Keshe plasma physics.
Right.
I'm looking at everything as a fractal. So you have actually what he's not also considering is the 7 modes. In other words, there's the atomic mode, then there's the molecular mode where you have 1 layer interacting, then you have 2 layers. You have to do it like that. And what I think he finds a very interesting thing about iodine, and that iodine, when you divide iodine from this 3520, you get, of all the heavy metals, it's the only one that harmonizes with biological structures, with hydrogen and carbon and all the rest.
And
so
it had a molecular weight that was a prime number, like 129 or something.
Exactly. So what I think is happening is iodine is 3520. It's the soul. And that's acting as the neutron that's dividing, that's creating all of the layers of everything else at our level of existence. So, and then hydrogen is on both ends. I think hydrogen is the container. So it's going to be 4 more modes up. I'm not sure if it's 7 tones. I think you have to go to the next tone. You have to go to B and then an octave above B, and then C and an octave above C, and you go through 7 modes. So you have the atomic level, the molecular level, the chemical level, the biological level, the emotional level, that's the 5th one, the soul level, which is the 6th one, the universal level, which is the 7th one, and then you get to the 8th one, which is the octave, which is the creator at the center on both ends. And I think that's hydrogen at extreme octaves. So, but at any rate, I still have to work that out. I'm not sure, but it's very, very interesting. I don't know, you sound familiar with it. Have you seen that? He plays chemical. I'm still not hearing you now. You're muted.
And I'm not heard. Yeah, I did see the video, and it's actually it's quite stunning in a way. And maybe we should put it, the link.
The health
if we could put a link, someone could put a link in the group chat
Yeah, I
like
have it
that?
somewhere, but I have to
Health
dig it up.
Ranger or something like that.
I can find it.
Oh,
I've been using
yeah,
it.
yeah. I think it was
I,
Health Ranger through Health Ranger
yeah, Mike Adams.
YouTube.
Yeah,
Health
yeah,
Ranger,
that's a guy.
I have been
Health
using it
Mike
to
Adams.
meditate and dance with, and it is fantastic, especially since we know about the elements. And in the video, he also does the sounds of lead and sodium fluoride and
That's right.
green. And
Yeah, right. Well, some of that I sort of take exception to because he changed the what's the word, timbre or tone,
Timbre.
timbre of
Yeah.
the instrument, and he should have kept it all the same timbre so that we could hear the discrepancies through the same tones and timbre rather than just changing. You know, there should have been some what do you call it, disharmonics there, or
Well,
unharmonic
the difference is
stuff.
when you look at the pitches, you see, and there's also the other thing is the every everything in the universe has its own pitch, which means that it has its own harmonic overtone series, which means that those are the isotopes. I'm sure that's what's going on. That's why you can take one thing Mr. Keshe will say, look at this, look at the isotopes, and he says, see how this has the same isotope as this other element that's got a different weight. Well, because those harmonic overtones. And so you will get sympathetic vibrations with those harmonic overtones. That's what's going on with that. So calculating the harmonic overtones as the isotopes and then figuring out the modes. That's a big thing, the Greek modes. They're giving us the information that was passed on. And I know it's 7 levels. You start as A as a tonic, you start as B as a tonic, you start as C as the tonic, and you keep going in layers like that. And you go 7 tones, and then you get the octave again. And I'm sure that that's what Mr. Keshe was saying in the kids' workshop, the atomic level, the molecular level, the chemical level. You just keep adding. First you have a single tone, then you have 2 tones, then you have 3 tones, then you have 4 tones, then you have 5, then you have 6, then you have 7, and then you have the entire spectrum at the octave again. So that's what's going on with that. I find that really fascinating. And I've noticed something. I've been trying to draw out the flower of life as spirals instead of the circles. And I've realized that if you have one spiral going in one direction and you make another spiral going in the opposite direction, they link up out at the 9th layer so that you get a ball inside a ball inside a ball. But I also noticed that when you do it that way, you get this egg structure so that there's an offsetting where in one layer, the egg yolk is off to the side. So when that's spinning, when that is, there will be 6 of those, and all of those will equal one big ball spinning equally as a circle. But each of those pairs of spirals, it's an oscillator. It's literally an oscillator. You have an egg yolk on one side and the egg white on the other. When that's spinning around, that egg yolk ends up on one side and the other's back and forth. So the structure of the flower of life, the structure of the neutron, of everything in the universe, is an oscillator. When it spins, it's going to spin and create a vibrational pattern from the fields because of the offsetting of the eggs type of so everything in the universe is a tone generator. And there'll be the 6 tones plus the 7th tone plus the octave and so on. I've worked out the container. I've worked out a lot of it. And this to me is a major breakthrough because he's dividing. He's dividing. So if you start with, assume that the iodine is the neutron, the center of your brain, which is everything's a fractal. So everything's a neutron. So you have the neutrons at the center of your brain, that's the soul. When that divides, it divides into this. And these are the harmonic frequencies that we have harmonic resonance to, even if we're out of tune with it. In other words, like a radio antenna. You oscillate, the Tesla oscillates the radio antenna. And if you have another antenna tuned to the same note, You don't have to power it. It will automatically start vibrating when it's in range, meaning the fields, if it's inside the range of the fields of the antenna, it will oscillate and instant energy transfer. And I was reading this sympathetic vibrations, harmonic resonance. Some researchers just a few months ago found that with sonic vibrations and the transfer of sympathetic vibrations, that it not only travels faster than speed of sound, that is, a string will vibrate before the sound gets to it. It's faster than the speed of light. And as far as they could tell, it was instantaneous. And that's because it's not at a distance. If you think about it, you have to be within the range of the fields of the radio antenna that's being transmitted. So your radio has to have fields touching the fields of the radio. So it's like Eric Dollard with the two guys standing on either end of the stage holding the rope. When he vibrates the rope, either transversely or longitudinally, the rope has to be in both places at the same time, or either way it doesn't work. Does that make sense? It has to be connected. So you're not really communicating at a distance. It takes both the rope, the fields have to be in both places at the same time. And then you get your communication, you get your harmonic resonance. So it's instantaneous communication, but not at a distance where they're touching. And I think that's what we see that's what matter is. Our eyes is an antenna array. And our ears are an antenna array tuned to the same frequencies, only so many octaves lower. Our sense of smell is nothing more than an antenna array. And as strange as it seems, so is our skin. Our skin is tuned to certain frequencies. And just like you can only receive what you have sympathetic vibrations to, what you're tuned into. That doesn't mean if you're not tuned to that radio station, those fields are not passing right through your antenna, they're right through you. So that if there's a person right in front of you that's not tuned to your pitches, your frequencies, you're not going to see him, smell him, hear him, taste him. He's going to walk right through you, and you're going to walk right through him. You will not be able to feel him. And I'm sure that that's what's actually going on. That's how people, Mr. Keshe was saying, kids are going to learn to play by walking through walls. Well, if you could change your pitch, now you're not in sympathetic vibration with the field strength of the wall. It's like a radio antenna you're not tuned to. You will go right through that wall, right? Okay, I got carried away with that, but
Totally
I'm very
agree.
excited to find this.
Yeah, I totally agree. I'm not sure about the iodine thing. We'd have to work it out to see if it would work out mathematically if you start with the iodine at a high place, like he had it low in the structure. It was like 20 hertz or something like that, I think. Maybe 30
it goes
hertz.
to A0, which is why I tend to think A0. I think all you have to do is replace hydrogen with iodine, reverse them. Give iodine the A3520 and give hydrogen the A, which is A7, and give hydrogen the A0, something like that.
Yeah, well, all the other ones fit into place neatly the way he had them set up, though, where they mathematically, according to their atomic weight, fall exactly in place with the right frequencies and so on.
Well, everything will stay the same because you keep the same pitch. You start out with 3520. You just call iodine A7. I think so, but Rick, I know I'm going.
It'd be interesting. We should try to figure that out, I guess. I'm not sure where to start on it.
There's something always inverted with this stuff because our perceptions are.
Well, it's true, and I mean, if you look at it in terms of reactors and nuclear reactors in particular, we have on the one end we have the heavy, plutonium-based, uranium-based reactors that deal with all the heaviest elements and create and work with all these radioactive, very intense elements with a long, half-life, and this is sometimes a very short half-life in many different types. But they're all heavy elements, and that's one type of reactor. And then the other end, we've got the hydrogen fusion reactor, and that's different, and where there's byproducts that may be, non-toxic and non-radioactive even in certain types of reactors, or very benign, let's say. And they're achieving the same goal, but at total opposite ends of the spectrum of where you get energy out of. So it's interesting that the hydrogen, in one sense, is it's a lightweight. It's the very lightest, tiny weest of things in the universe. At the same time, it's the basic building block. And at the high end, we have these heavy elements with multiple huge atoms, and you could take them apart and use all the tiny parts of them perhaps and create other materials with them. And it's a different perspective, though. One is the hydrogen. Starting with the hydrogen is like an additive manufacturing, where you add to it to create your thing. And the other end, starting with the bigger molecule, is like a subtractive manufacturing, where you take stuff away and you end up with something at the end of it. It's two different philosophies.
I tend to think hydrogen is on both ends of the spectrum. It's the lowest octave and the highest octave, and so everything is dividing. I think that's the secret of monoatomic hydrogen and all this stuff about hydrogen, why it's so important, because I think that's the container. I think that's the outer edges. But the question for me is, how many octaves up? I think you have to go up maybe 7 more octaves, maybe 7 more octaves times 7. I'm not sure.
Well, I was surprised that he limited it to, what'd you say it was, at 3420 or something?
440.
Pardon me? What was it again?
3520, which is A7. That's the highest.
3520.
He's
Okay.
just using.
But that's the high. You say that's the highest, but why not take it up to a 10 or 20 or something?
Well, that's my point. I think that's what's happening. But what he's doing is he's using the audio range of a human. The 7 octaves. That's
but
human.
we could go much higher than that to
Absolutely.
get to the to still be in the human range. Most women, especially, can go over 10,000 hertz, for example. Most men up to about 8,000.
You need to go probably in both directions, many more octaves.
I'm thinking that if the hydrogen was higher to start with, then the lower octaves we'd be able to hear better. Like some of them are so low, like the iodine and others, the lead, that it's actually below our hearing level, like into 20 and 30 hertz and so on, or less. And so that we can't actually hear those elements. I'd rather have it double or triple the frequency, and that would get them up into the hundreds and be able to hear those
no question
ones.
We have to transpose these elements into our range anyway. And I think what he's basically doing is he's just giving examples of how certain elements harmonize and others don't, certain ones. So he's basically just showing the principle, I think, right? But you're 100% right. I'm sure there's many, many, many more octaves. But certainly you go up 10 octaves, no human can hear it. So that doesn't mean that that's not where hydrogen is. It probably is. It's probably, at A70 or A108 or however many octaves up. And it probably goes down to A minus something or whatever. So even for us to be able to visualize it, we're still going to have to transpose those into octaves that we can hear. I mean, even A0, you can't really hear it. He had to take that up an octave, and then it's mumbling so low that you can't. He had to take it up 2 octaves, and then he goes, see, it's in tune. So that's the point of it, right? But yes, I think so. Finding out how many octaves we need to get the entire periodic table. And I think it goes with modes.
Yeah, well, that's the other factor, is these modes that you bring up. And by that you mean going from atomic to molecular and nano and so on. Is that what you're talking about?
Yeah, and the
modes?
way it works is you start with hydrogen, and you call that the tonic. And then you get the next note, G, going down, or B going up. That becomes the tonic. So you have A, B, C, D, E, F, G, A, and then you go B, C, D, E, A, B to B, C to C. And there's a very interesting thing how it works out going backwards. How when you go from A on the inside and you go down, you have A. If you look at it as a neutron, you have 12 fields spiraling out. When one field intersects with another field going in the opposite direction, they do what Mr. Keshe explained a couple of weeks ago. He's done a lot of different analogies, like burring a hole into a piece of wood, where the fields balance out and create a secondary central core. So you have a primary central core, fields going out, creating another secondary central core, and then the difference between those two fields is the sawdust, equal to the difference of the mass of the wood and the hole, or basically the difference of the pitches or the mass of those two fields. And there's 12 of those, and they create a ball. So you have 12 balls around a central core, 12 secondary fields, secondary central cores that create your circuit. Then each one of those has its own sawdust that creates a replica of the original, and it has its own central core. And there's your Coulomb barrier. And that's A. And that whole thing has a pitch of A. Call it A, whatever. When it goes, those fields go out again, the second set of fields radiate out, they cross. And now you have the difference of those 12 fields. So you're going down in orders of magnitudes as far as the mass goes, because now it's only the sawdust is created the first 12 fields, now your balls, and now you have another one. So you go down to the note G. And then you go again, each one has a container. So you have a fields radiating out, 12 balls giving you your Coulomb's barrier. There's your complete sphere, the fields going out in a container. Then it goes out another layer to G. Then it goes out another layer to F, and then E, D, C, B to A. When you get to A, that's a replica of the original one. So now you have an octave of 7 layers with 7 notes and a replica of the original note. That's your total plasma structure, but you need a container for that. So then you go to the next layer out, which is going to be a G again. So now you created in my image, an A octave with the 7 notes in between. With the container becomes a G, which now means it's confirming the existence of the G. And then it goes out that octave. So that's your second mode. Your first mode's A to A. Your second mode is G to G. Then you go F to F, E to E, and you have 7 of those octaves. And then when you get to the last 7th mode, the container of the whole thing is an A again. So you have an A octave higher, and an A at the central core. And that's the way it works, I think. And there's your 7 modes. From the outside in, the first mode would be the last layer out, which is the container. That's only one layer interacting with itself. Then you go to the second mode. Now you have not only the fields of the B, but you also have the fields of the A in the second. So you have an A and a B. So now you have molecular. And then you go to the next mode and you have chemical. Because so you keep going up, adding more layers. You have more fields interacting. And that's I think, the way it works. But I still have to work some stuff out. Anyway, I have to go pick up my passport. It's going to take me about an hour. I think I have to leave to go back to China tonight. And I had to get a stamp on my passport for my re-entry visa. So I'm going to have to go. Hopefully I'll be back in an hour and catch the rest of the show here. So thank you, guys.
Mario. Always
and
good to get your insight.
Talk to you next week.
All right, very good. Thank you.
Thanks.
Always good to get your insights. Yeah.
Yeah, thank you, man. See you guys.
Okay.
See ya. I just wanted to say something about what Mark said there. There's a history of music actually where nowadays in an octave they have 7 steps, but originally they didn't have 7 steps. Originally, for almost 40,000 years, human beings are known to have divided the octave by 6. And what happened is that a pope, his name was Ignatius, in the 1600, I think. I'm not really sure about the dates. That decided to change the spacing in an octave to add up another note, and this one has been called SIC. And so do, re, mi, fa, sol, la was the original one, and then it finished with do again, or it started with the very first next octave. There was 6 steps, not 7. And his name was Ignatius, Sir Ignatius, so S-I became his note. And he's the one who actually kind of changed all these frequencies, if you can see it. And I discovered something, because the flower of life have 6 petals. And when you look, and of course you can equate music with color. And it's a pure science, actually. And there's the 3 primary colors and the 3 secondary colors, which is 6 again, if you think about it. So here I just want to show maybe a little something that I heard before and I found quite interesting. It's that little thing there. I don't know if I...
Let me get the camera better here.
That's pretty good. There. Okay, so instead of doing 7, I'm gonna do 6 spacing in my octave.
I can't see that because the light's...
Okay. It's a bit more better like this.
Maybe if I turn
Yeah.
that off, that'll be better.
Yeah, that's better.
Yeah.
Okay. So anyway, so I divided in 6 instead of 7, and there's that little trick where you just keep going till 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you do 1, 2, 3, 4, 5, 6, 7, 8, 9. And here you got the original notes. You see, nowadays they do 440. It's because they raised it. They had to put a 7, like I said, 7 spacing instead of 6. So they change all the little thing. Here what I'm doing is I'm just kind of reestablishing the original, what they call the Gregorian chants. Those were the original frequencies of these, and actually they turn out to be the 3 primary colors and the 3 secondary colors. But there's more to it. There's actually a doctor, I don't remember his name, but in the 1990s that won a Nobel Prize in medicine, in genetics actually, because of those notes. And what he discovered that if you use the not 173 or 175, it would have to be exactly that frequency that suddenly the DNA reacted. And let's say, I don't remember exactly, there was all of these were giving an order to the DNA.
Yeah, I know that. I think it's the 528 that they use to recombine DNA in the laboratory. It's able to
528 is right here.
Yeah, it's able to allow the DNA recombination process, apparently.
Yeah, and the guy won a Nobel Prize because they couldn't really cut the DNA perfectly. And with one of these, it precisely cut the DNA without
That's
breaking
right.
anything.
That's
If
right.
they use the other one, it glue the DNA. If they
That's
use
right.
the other one, it repair. I think there's one. It's called the Miracle One 396, which I think is me, and me for miracle because this one repair the DNA, and they are in very much resonance with our DNA. So here, what I'm saying is that they change music. They change all these by putting 7 step instead of 6, like we always use throughout history. They change basically the law of music, and what that guy did was just to reestablish the original notes, which are called the Gregorian notes, and discovered that they interact directly with your DNA. And again, here it represents the 3 primary color, not in art, but in light. The light spectrum.
Right.
So basically, here it's the 3 primary colors and the 3 secondary color of the light spectrum. So just a little
Very
bit
good,
tidbits there, just to add up.
Anybody want to add something to that or question about it?
I just want to say this is fascinating. Absolutely fascinating.
Yeah, it's cool, eh?
Yeah. I also
It
want
is.
to just add back to the Elamonics music. At one point, early in the 4 minutes, he's got 2 downloads. Progesterone kicks in, and my roommate and I, she and I go nuts when progesterone kicks in. And whether
Your roommate, sorry, you broke up there.
Oh, I'm sorry. My microphone was up. My roommate and I dance to Elamonics a lot. And when progesterone kicks in, we start laughing and having so much fun. So um, I think Doug did say to me, if I'm enjoying it and it makes me happy, it's fine to use. Like, I don't want to be, I'm trying to use this to teach people about the invisible elements the way that I can, which is through breathing and plasma waters, but also trying to get down to the very basics that it's all around us. And this music seems to be the way to help us see the invisible because we can hear it, which is invisible. But then you add in that most of the elements are invisible. It just seems like a natural coalescence. So thank
Well,
you so much for the clarity.
that's a good point, and something I wanted to bring up in tonight's meeting was this idea of, let me get my webcam under control here. Back, boy, back. The idea being that what if, according to some religions and some schools of thought, the entire universe is created and exists because of 2 factors, one of light and the other of sound. And there's actually quite a few belief systems that are esoteric systems that believe that the universe is actually created from the interactions of light and sound, which makes sense because if 99.98% of the universe is plasma, then the only way to interact with plasma is either through light or sound, essentially, a type of sound. We talked about longitudinal waves a few minutes ago, for example, and the idea that there's different types of waves. It was if you have things that are connected with a rope in between, and you can shake the rope and it'll provide a wave through the rope and eventually get over to the receiver at the other end. But if you tug on the rope, the receiver on the other end receives that immediately. That's an immediate communication back and forth. They're both linked in real-time, instantaneous communication, as opposed to a wave that takes time to travel in between. So we're looking at it's funny when I say that, because in the old days they used to have these tin can communication systems where you have a tin can with a string tied in the middle of it and it goes over to another tin can of your buddy a ways away, whatever, you could pull a string in between tight and you could listen and talk into this tin can. And in a way, that was more real time than the communications we have now, which are based on waves, because this would have been a direct pull on that string to the other, from one transmitter to the other receiver. And it's just a tin can, but yet that string is pulled tight, and every time the vibration happens at this end, provides a vibration exactly at the other end at the same time. There's no real wave in between. It's that instantaneous string action. So the old-fashioned kids playing with a tin can telephone may be closer to reality of receiving that signal instantly than we do with most of our communications systems now. They're trying to get into quantum communication systems that are more real time than what we have at this time. But so far, they're still sort of on the experimental realm, as far as I know. Okay, we've got, what have we got going? Just checking messages and so on. There's a question in the live stream chat. Hey Rick, how do we help those who are stuck in 2016? Well, that's a good question, I suppose. Well, we all have to get out of 2016 somehow. So it's two words that come up the other day, which is forgive and forget and move on. So
And buy them a calendar.
buy them a calendar. There you go. Get a 2017 calendar. That helps you get out of 2006. That old calendar on the
Friendly
fridge that's been
reminder.
up there for 3 years. It's time to get it down. So anyway, what's I gonna say here? Okay, I think Mark had his video up there. Is something you wanted to show us this week, Mark? Maybe it's time for that.
Yeah, I'm not ready to cut.
Or does somebody else have something they would like to present or talk about at this particular point in time? Anything else about the vibrations that Guy brought up, or anything else you want to bring up at this point? Other than your dinner, we wouldn't be into that so much.
That you can keep.
Those gifts you can keep. Those gifts we don't need. Okay, so anything else at this point in time? Or do we bring on Mark? And whatever magic he might have. Well, Mark, bring it on. Bring it on. What do you got there? Huh? We can handle
Hi,
that.
Rick.
Big
Hi,
Hi, Mark.
everybody. Yeah,
There
you
you
know
go.
me. My settings might not be right because I just wanted to have an open shot like this because I want to go into a tight shot. And it's just funny how everybody's, from Lee. I love it when Lee starts out our session because it seems like he sets the tone.
Mhm. Yeah, and it's usually a little bit funny and a little bit light, and at the same time, right into the core of what we're doing. Yeah, it's good. I love it.
So, following on the heels of Lee and everybody else now, and Mario, I have some things that happened this week that absolutely confirm everything that we've learned to this point.
Right
I don't
on.
even
Well,
believe it myself.
you're just I'd like to say that your workshop looks very neat and tidy there. It looks like you've been really at it to make sure everything's in just it looks beautiful. Really nice work there, Mark. I'm jealous to the nth degree here with all the stuff I've got scattered around my workshop. So congratulations on that. Thanks for being a good example for us.
Not that part doesn't really matter to me because observation is everything, and it's just my habit. Like we talked about, I'm from Detroit, so when you're born and bred in repetitious type of an atmosphere, which I'm still trying to break because this is the end results of 57 years of being told what to do.
Yeah, it's all about production in Detroit, eh? Production. So,
Yeah, and that might be a plus or a minus because from my point of view, I observe everything, and everybody that I've ever worked around was always, I seen the unneat people and I seen the neat people. I seen the productive people and the non-productive people. And when you work in that atmosphere, you have a choice. You make a choice every single day when you go to work. And do you want to be around the people that are non-productive? Well, sure. You can. That's a very easy path to choose. It's a lazy path. It's a non-productive path. You can make it if you want because other people will protect you. You know, in Detroit, you're protected by a lot of people. Even if you do misbehave a little bit, you're still protected, and we know why. You know what that's called. I'm not going to embellish the name of it, but you're protected. And I don't think that's a very good way to, we're individuals that want to be protected in a family that are productive people, or at least I want to be around people that are productive.
mm-hmm.
So, when I went to work, I stayed around people that, made my work atmosphere look like my shop here. Plain and simple. I don't know how else to make it or say it or do anything different. It's just how we're all brought up, I guess. So, so thank you for at least acknowledging that I am a neat person, and I do try to have a little structure anyway. And tonight, I've been blessed with this these observations that I haven't had many pluses over the past year and a half. You know, I've been working hard with a lot of stuff, and I don't. You work in a field that you don't even know what you're doing. There's no manual. There's no nothing. There's nobody patting on your back. You just go about your business and hope that you see something that might be different than something that is out of the norm. And we keep, you see in Facebook, you see people doing stuff, but I worked on a lot of stuff and I haven't really seen a lot of results. But man, this time the results were unbelievable. And it was inspired by Lee because he started freezing his stuff. And I live in Michigan. It's cold here. And Lee lives up in Canada. And Rick, you guys live in cold conditions. And so it gives us a model to work with. For whatever reason, I'm not a smart person, but I thought, well, if Lee could do it, I could do it. So here we go. And I've thought about this for the last couple of days, how to present it, how to do it, and it might crack, and I don't absolutely know exactly what's going to happen, but here we go. Okay. Well, let me turn my monitor here first because I have all the gains, because you're going to have to kind of talk me through it, Rick, because, see, because it's ice. Steve.
It's alive!
It is really alive because I got a couple of things to talk about, but Rick, can you help me a little bit?
Talk you through what now? You want me to tell you when your ice is going to slip?
Yeah, you could do that because you're Canadian.
All right, I'll do my best.
But no, I need your help for when I start to bring the camera close for the games, because then I'm going to have to sit down and try to monitor, so that we know what it looks like. Because this is going to confirm everything that we've been talking about for the last hour and a half.
An American puck.
So that's too hot. Wait, let's see how hot it is.
Mm-hmm.
Still hot. Can't see anything.
Put water on?
You have to help me here, Rick.
You need to change your.
Maybe the reflection of the light.
Do you have access to advanced settings on your webcam,
Yes.
like
Yes,
br-
I'm ready right
brightness,
now. On the camera.
brightness, contrast, color intensity, and white
yes.
balance?
Exposure, all that stuff, gain, brightness, contrast, color, and white balance.
Yeah.
start
Well,
with
you need to
gain.
turn most of them down. Go ahead.
You need to have the light behind that and not in the front. Otherwise, it will reflect.
Yeah.
So make
That's a good
make the
point.
lights go through it.
I have it above it and below it.
Yeah, Mark, start with your gain.
Yeah.
Okay, gain down or up?
Down.
That's it. That's buried.
Wow.
Ah,
Oh, there we go.
What
Now we're
about?
starting to get.
it's
Do
getting
you have
better.
brightness? And what about
We're
brightness?
starting to see something.
Okay. That's better. That's getting a little too extreme. Maybe.
Look at that.
Right
What
about there, I
about
think.
how about contrast?
Contrast. Let's see. Your white balance. No. I guess I'm going to have to move the camera a little bit. I could see it a little bit better before. Because, well,
Yeah, try changing your lighting a little bit. You might not
See, when
need
he-
the above lighting,
If
for
you
example.
reduce the light above, I think it's going to be a bit better.
a light above off.
Yeah, try that.
Or maybe too much.
Yeah,
Or
it's
light up.
or the one above and not the other one. I'm not sure, but okay, we can see a little better. Yeah, that makes a big difference. Now we can start
Maybe
to
play with
see
the contrast.
some of it. It needs a little more lighting in behind now. It seems like.
Behind?
Well, that would be best. That's generally the way to do it.
Oh, okay. Well, maybe if I just take this down
Try-
and stick it behind it. Hold on.
Or try a flashlight maybe or something and just see.
Oh, I have a flashlight. Yeah, let me see
Just
that.
to experiment with to see if it works.
It's unbelievable what you're going to see once I get it going.
It's hard hard for the light to penetrate that. It seems.
Well, it's a cube inside. Maybe I should. Do you think I should try to get it out of the plastic?
Oh, probably, yeah. As you get frosting and stuff that happens, it's.
Where's my gas? But I don't want it to crack. That's what I was worried about. Because it's a perfect sphere, and all the we talked about how all the bubbles are coming out from the sides.
Mm-hmm.
This oh, it's cracking. Hold on. Oh, it's out. Hold on. It's out. Beautiful.
All right, we're getting there now.
It seems to be clear.
Yeah, now try bring your gain up. Well, I guess you're gonna have to sit there and hold it.
Well, wait, let me just put something behind it. Something heavy, huh? Okay, there. Stop.
Okay.
Yeah, if you bring your gain up just slightly, slide off the table.
It's a chunk of ice.
On glass or something, yeah.
Hold on. I'm gonna have to get something to hold to balance it.
The other option would be to set it on a piece of paper. Give it some texture to grip onto.
Yeah.
Good idea, John. Hold. But then that's white. Okay. Oh. Well, that's what happens when we're live, right?
I love live TV.
This is great action for
Just
live
maybe
TV.
little
We
strips
love
of
it.
paper. Little strips of paper instead of the whole sheet.
Get back to the computer here and see if I can't get the gain better. Okay, now
There we go.
Okay. That's too much. We still need, I think, some alterations to the lighting. It's seems a bit too bright. That's getting there now.
Yeah, your white balance and your saturation aren't going to help with visualizing. It's going to be a balance between brightness, gain, and contrast.
Brightness. Okay. Gain.
Quite nice there.
No. Exposure.
Right there. No, where it was there, one notch there. That's pretty good. Whoops.
Oh.
Who's
David.
David IP, you're sharing your screen. Okay, we can look at that after we're done this one, perhaps.
I don't know. Maybe that's.
So we can see the cube inside. What is the cube?
This is what's inside
Oh,
the mini magrev.
In what way? How is it orientated? We can't tell where the coils are. Just like that?
Just like that.
I see.
So, can you see the configuration of the?
So the black things that we see on each side, those are the coils? There
Inside
and there?
here?
No, yeah, right in the middle.
Here and
right in the
here?
middle.
Yeah.
Yeah.
Yes.
Oh, right in the middle.
There's a coil here with a line going across here,
Yeah.
but everything is coming up and down and just absolutely shooting all around it. And it has consecutive rings going this way and going down this way. And it blew it up this way. I wish you could, if somebody was here to see it, you could just. Yeah.
no, we can see the pattern.
Yeah, we're starting to be able to see it better and better here as it gets zeroed in.
Is it consistently spherical from the top, or do you see the three lobes in the pattern as well?
John, if I would just send this to you. It's so beautiful. I can't even explain it to you. There's so many different fields of patterns of fields that the magret that these little are just throwing off. It was like Lee said, it was a perfectly. I used distilled water. It's just a nano coated the three with the one in the middle, and the fields on it are just incredible. You try to get a little closer.
Oh, that's a good angle.
Start to be able to see better there, some of the detail. Nice, yeah. It's nice when you rotate it and hold it in different positions. The positions give us the detail, and the rotation gives us an idea of the position and so on.
Depth.
So you can see it's like an
Yeah.
actual flow, an outward flow from the magret, the mini magret.
Yeah, you can see the curvature there of the fields, which normally it's the bubbles seem to travel in straight lines, but there seems to be a curvature there. That's interesting.
Oh, absolute curvature. And if you look over here, there's rings that go this way. And I don't know if the camera's picking them up. I know they're not because of the back.
I don't know about you guys, but everywhere I've ever been, bubbles don't go down.
No, absolutely not. Oh, that doesn't help. Let me try this. Let's try. And where's the down? Where's the other?
You said maybe from behind.
Yeah, it's just that light's a little bit strong. It's oversaturating.
Okay, let's try the.
There we go.
No, it's just not enough. Darn it. How do we get that lighting right?
Well, what about the flashlight right in the middle on the top, pointed straight down? It's not enough to get the camera to focus.
No, that's not enough. No, I liked it better from the bottom. Okay, so this one, that was number one. So this was my first idea of just stick, because I wanted to see what my mini mag ravs would do. But if you were standing where I'm standing right now, you would say to yourself, this is giving off a field all the way around it towards me, an outward bound field. It's going up. All these bubbles are going absolutely in a totally different directions, and I'm just wondering if all these little things that are coming off of it are hydrogen that are being made by the magrav. What do you think about that?
Oh, that kind of came up a little bit earlier. I don't. I would have to say no. Probably not. They're likely, from what we've seen in a number of different experiments, the space right around where the field is strongest freezes last. So I would be inclined to think that would probably be just the trapped gas being forced into the elongated type bubbles as the water freezes around it.
Yeah, I would think it would be trapped gas. That's generally the case. Gas being like atmosphere, whatever was in the room at the time, generally nitrogen, oxygen, and argon combination that we breathe. But
yeah, but that would be just like one coil of that unit. You know what I'm saying? That's just absolutely blowing that up on that one corner.
Mm-hmm. Yeah, well, that's the thing about it. If you think about it too, there's a chance the coil itself could be still nano-coating itself inside there, pulling off oxygens out of the H2O of the water and liberating hydrogens into the water and off-gassing them along the paths of the field lines essentially of this device. So that is possible, but it's more likely that it's just dissolved gases in water, because it's really hard to get water that doesn't have dissolved gases in it, even if it's distilled water. But
okay.
It would be interesting.
Now that I've challenged your thought process,
yes,
here we go. Because this is just a little block of ice, and this was just a fun little thought thing. But guess what? I went a little farther than this. Aha.
We like surprises.
Yeah, we're waiting for the grand finale here.
Well, because Lee put his stuff outside, I'm inside downstairs in the dungeon, so I only have what I have to work with. So we'll just take it over here. Don't lose my cord here. Get up, over, over. Here's my ice box.
You'll need to run back and set your camera on automatic again.
Okay. Oh, that's right. Okay, let's go to auto.
Clink, crash, smash. Oops. Wow. Oh,
Dark.
darn. I really
It's
like
dark.
that vase.
Right. Dean.
Okay. We see some sign of light there.
Okay. So light. What? Let me just turn this light.
Plasmified his icebox.
Oh, don't tell me my battery's gonna go bad on me.
No. No.
Oh, yes, yes.
This is like the Batman show then, where stay tuned next week while we have the sequel. Will Mark show us the inside of his refrigerator? Or
Hold
will
on,
we be
folks,
left
the
out in the
Batmobile
cold?
will be right back.
Interlude.
I can't believe the battery, of all things, to go right then and there.
Yep, that's the way the Batman movies work too. And they make you wait till next week to find out what happened. And then nothing really happened, and they just continue with the story with. And so Batman got out of that situation by
Then
leaping
wham!
across the chasm. Whatever.
Well, fix that one. Go to the next one. Gotta have backup.
This always happens in those critical moments when people are about to reveal deep inner secrets of their refrigerator. Okay.
No, that's not going to be enough light, is it? But I got backup to backup.
We see
we get the
jumbo hamburgers. Okay, we see something in the upper level of the rack there.
And I just started these, and they're not completely frozen yet. So that's what I don't want to take them out.
Okay. Well, this is your rotating, what do you call it? Merry-go-round thing with all the little guys on there. Yeah.
Yes.
So it's still juicy in the middle?
Yes.
We see a very nice sphere there somehow.
Can we see that?
You can see the fields sort of working toward the middle again there, but in a curved fashion, are they not?
Yes. Everything started from the outside, from these outside pods, and they're now starting to work towards the middle. They started out in a ring form, and they actually grew a ring all the way around the container. Once the ring was formed, now they're starting to shoot up towards the center.
Yeah.
And if I put the light behind put it in back behind it, I don't know if you can see it. It's not complete. In the middle, there's no water. It's still liquid in there.
Mm-hmm. Yeah.
It's not, and it's been in there 24 hours.
Mm-hmm.
But on the top upper layer here, there's a vortex that's coming off the center post. It's actually pulling away from the post. There's a clear area away from the nano coating. And there's small bubbles that are going up constantly through the water towards the top. I don't know if you can see that or not.
What do you mean constantly? Like actual bubbles that are floating toward the surface?
Yes.
Oh.
Could that be
hydrogen? It's a constant movement going. I don't know if you can you see it?
So,
can you see that?
Like Guy says, could that be hydrogen? Where's it coming from?
That's what I'm thinking. That's all hydrogen that's being made right now.
Does it come from the actual nano-coated material, or does it come from the bottom of the container?
From the bottom, way down on the bottom.
Mm-hmm.
I don't know if I can you. Oh, it's so dark. That's why you can't see that. Huh. I'm looking at it. Oh, look at all them bubbles going.
Yeah, it's hard to see the bubbles, but maybe now.
There's an interesting stratification along the bottom too. That's kind of unusual.
See that, John?
Yeah, very well. All these tree ring layer type of thing.
And it's all moving to the center. Everything's growing to the center. And actually, I think if you really look at it, there's a dome in the middle of it so that it won't penetrate. It's almost like it's moving up it and won't go towards it. If you know what I'm saying, there's a wall here where they're all growing to it, but it won't penetrate into it.
Raise the
Does that
camera.
make sense?
Yeah, we're looking at your thermometer.
Oh, sorry. I got the door open. Oh, it's really getting hot now, huh?
Yeah, it's starting to be about freezing in there now.
Yeah, but it's actually raising now. If I can just show you one more thing, because I don't want to take it out yet, because it's not finished freezing.
Maturing.
So that's one. And I don't know, this one has no nano in it. It's just the pods, and you're not going to be able to see it, but there's an actual, can you see the dome it's making?
It's there. It's just really limited.
Dang, why is
Oh
it?
yeah. Oh yeah, I see that.
Wait a minute. Do you see that around that dome on the outside? Right there on the bottom. See
Yep.
that?
Bubble?
Yes.
Oh yeah, we see it clearly.
Mm.
Yeah, that's what I would expect to see with freezing water that's freezing from the outside in.
A big bubble on the middle.
Well, not in that specific configuration. You would assume that it would, if your temperature is equal on all sides of the container, that it would grow equally. In this, we see it's really thick on the bottom and really thin on the sides. But I would expect to see, this sphere growing from the walls towards the center as the water freezes.
Yeah, but now the bubbles, now the sphere in the middle is actually pulling the bubbles from the container in towards it. Whoop.
So it's not finished frozen yet.
Oh no.
Okay, so this one too
I
is.
don't even know what it's gonna look like once it's done, Guy.
Mm-hmm.
Why is all that lines in it?
And all this is distilled water,
It
eh?
looks like there's interference coming through the camera.
Yeah.
I mean, like there's fields coming through it where I can't get those black lines out of there. What in the world? Why can't you get that out of there?
You did it there for a minute. Yeah, it seems to be better there.
Right there.
Pretty good.
Yeah, but take note, folks, that with this one, we're not seeing the lines of bubbles. So, we've definitely got to have different conditions in the other systems where there's nano-coated materials. Because I assume the water came from the same jug too, right?
Yes, it's all from the 5-gallon distilled jug.
Mm-hmm. Well,
so your quantity of dissolved gas would be more or less equal.
yeah, should be relatively the same conditions that way. The containers are different, I guess, and that might make a difference. But
Can you see that?
Yep.
Now you would expect that, right?
I would expect as the water freezes, yes, it's going to create a void in the center that's going to work its way towards the center. Certainly, it's just like ice cubes. If you put a water in ice cube trays and you stick it in the freezer and you take it out too early, the center of your ice cubes are still liquid.
Okay, then how do you explain this?
Well, this is exactly what I was saying. We've got two basically the same systems with slightly different conditions, and we're getting dramatically different results. Which kind of goes to the people that are saying, yeah, well, water freezes and you're going to get bubbles in the water, and you're going to freeze the bubbles in the water. It's no big deal. But this shows that yes, there are definitely different energies in the two different systems.
Yeah, because this is actually making something here. This is, without a doubt, these rings started this way in this one and built from the bottom up. And if you were looking at it, I can count at least 1, 2, 3, 4, 5, 6, 7, 8, at least 10 little individual rings going all the way through it, all the way around before it starts to jet towards the middle.
How many coils, or how many? What's the count of coils on your outside small satellite coils?
No coils in here. No coils.
Oh.
Nope, just a nano-coated wire that goes through that that's in GANS, and my dry powdered solution with a nano-coated wire holding it.
Oh, okay.
No coiled wire at all. The center coil, the center pod has a coil in it with copper, brass, titanium, and nickel in it.
Okay.
Center coil in there. And then there's nickel and titanium on two of the nano-coated wires just to have a different gradient.
Does the pitch of the stratification in the water correspond in any way to the pitch of your coils?
Say that one more time.
The pitch of the stratification of the water, the lines you see in the water that circle around,
Yes.
is there any correlation in that pitch between the say the light band and the dark band of each of those stratification layers? Does it correspond in any way to the pitch of the coil? I assume you're using 14 gauge wire, right?
Yes.
And it's tightly coiled?
The stranded copper wire was just I think it was 16 or 18.
Well, I'm trying to come up with some, a direction as to why we're getting this stratification, and I'm curious if the pitch of the stratification is equal to your wire diameter on your coils. The pitch of
I gotta
each.
shut my freezer before everything melts.
Yeah, that's fine. If it's equal to the pitch of your coil in the center, that's very interesting, because that may show a correlation between the actual field interaction between each of the I can't even think of the word, the loops of your coil and the fields that it's creating, like kind of like a standing wave in sound. Sort of what I'm thinking. I don't know, maybe Rick, if you understand what I'm talking about, you might be able to explain it better.
Well, definitely, it looked like a sort of a virtual representation of the coil itself, but in fields rather than the physicality. It's almost like a reflection of the plasma of the coil is, shows up at the bottom of the container. Yeah, I don't know. It's
Hold on, stop. Hold it right there. Rick, if you notice on the left side of this, we've got that little bits of stratification again. You see that?
Yeah. It's true.
And then
That's very interesting.
it would be this. It would be this side for you guys, right?
Yeah, it'll probably be your right.
Yes.
They look
It's like
that
that at every corner, and it's around. And on this one, the rings I can count 1, 2, 3, 4, 5, 6, 7, 8, at least 8 or 9 rings that I can actually see. A stratospheric ring around, and it's consistent around the whole thing. It looks like it blew up the middle. So if you ask me, the energy came in from the bottom, went through to the top, and came out the sides in a
Yeah.
perfect sphere.
But if we look at those
Field
layers,
boundaries.
those stratification lines, would it be plausible to think that we're looking at a standing wave within the plasma field flow itself?
Absolutely.
That's what it looks like, but on the other hand, we have to dismiss first the idea that it could be just simply the cycling of the refrigeration unit.
That's so true. Oh, I'm
And
sorry.
it's freezing a little, so the temperature is dropping down a few degrees and then up a few degrees and down a few degrees and up a few degrees. That could be producing that syndrome there. So you've got a refrigerator thermometer, right? But does it record, or does it give you anything other than just the instantaneous temperature, I guess? Is that right?
It's just ambient temperature inside.
Right. It'd be great to see a chart of a typical freezer, and whether it actually does the temperature vary.
To
like
keep a thermometer
5 or 10 degrees, which would be enough to give those layers.
If you
and
could,
how long was this in for? You said it was in for a day, was it? Or?
No, this one actually that we're looking at now, I started this on last Friday.
Okay, so several days, let's
The
say.
ones that we were looking at in the freezer only started at 20. They were actually in there only 24 hours. So after, like this one started out like those, clear as a bell. And then, like I said, in the center core, there was a dome that started because it was probably not, it was warm, kept itself warm in the middle. And then once it started to freeze more and more of these projections started to come out from it, from the dome, from the middle. So it just actually pushed out these fragments that were echoed through the ice and the water. That's the only way I can explain it. And I've been watching the other two inside there doing the exact same thing. Once the round one started in a circular form, it connected to all 4 pods in a circular form. And then another ring built upon that. And then another ring built upon that. And then another ring built upon that. To where there's now 8 or 9 rings. And now those bubbles are starting to push towards the center core, where this one is pushing away from the center core. So now I know I'm just going to do a few more experiments with some of my my different rings. To be able to figure out now which ones are pushers and which ones are pullers. So it already made me decide on my bigger unit here that what I'm going to do is, because the gain is off. What just by looking at that, what I did was I redesigned my core, my moving cores, because these cores were going to be made from the same thing that I just put inside the ice. And by looking at the core of the ice, I decided that that actually makes a whole universe of energy. So I don't know if you can see, I wonder why it's so dark today.
But all your buttons are here.
Probably your brightness control. Or contrast of it. Brightness looks like it.
From that last frozen bit, I could even see direction.
Yes.
From where it sits.
Better.
The fluctuation of the fridge, as Mr. Rick said, it creates also an environment that it has to interact with like the fridge is another component where you're putting it in. So according to your conditions, where the fridge is, it fluctuates, and it was really nice to see that. You could even see a little sort of coma, like a direction kind of bit that wasn't frozen or just like shaped. I mean, there is a wire. There are wires going on in the fridge, the surface of the fridge. Then that indicates many other things to me.
Yeah.
I was thinking about the stratification and what Rick said about the cycling of the fridge, and I would surmise that if it was a function of the cycling of the fridge, the outside layers would be very, very thin, and they would grow wider as it got farther inside towards the center of the bubble, because the core temperature of the water is going to drop. The slight couple of degree difference that the fridge makes when it cycles through is going to make a greater effect as the temperature of the water drops. So it would be very thin on the outside, and they would grow as it goes to the center. But I didn't see that in those lines. They seem to be all the same, roughly the same spacing, same pitch.
Yes. And if I rotated that round container, the same pitch would be exactly the same thing around the whole thing, whether it was on the front of the freezer or the back side. I thought
Right.
maybe because the back might have been a little bit colder than the front, that it might grow a little bit faster, but no, it's completely consistent around the whole thing.
So it would be easy to actually do a test, like do maybe a bucket with only distilled water in it, and then see if it does those concentric rings. No.
Mm-hmm.
Well,
And then we would clear that out. But I got
true.
one more thing. It's if you guys put one of these coils, it seems that it keeps a bubble in the middle. That it takes some times that it freezes over. It would be nice to see one that has none whatsoever and see if it does that bubble and if it freezes much faster. So now we know that there's something that actually slows down the freezing over from the inside, by having a test one on the side, just to have a good comparison.
Right.
Yeah, some of the experimenters have done that, and they've had their systems in the freezers for several days, and the center core is still not frozen.
So
No,
it's
right.
obviously the field that actually resisted the freezing.
Yes.
There's some evidence to suggest that that's probably what's going on.
Well, that's where the energy is held, and the ones that are in my freezer right now don't even have GANs. The big tall one that's making that's just nanotubes with GANs in it. I just had those extra pods because those were the first pods that I had made with to spin. So I just hot glued them onto a plastic container like that, just to see what would happen with no nano material in it at all, no copper in it at all. It's just pure GANs material. Just, and I know exactly, I wrote down how much is in each one of those tubes. There's the three containers were CH3, CuO, and CO2, and then on the very bottom one there was lead. So I don't know if that makes a difference or not. So that it's only been in there 24 hours. So we'll see what happens there. The other one, the spinning one that I put in, the round one, that has each one of the components, and then the fourth one had all three, the combination of the three. The center nano-coated tube actually has the mixture of what Mr. Keshe told us to have as a center core, and I have that written down. It has to do with all three combinations of the three GANs materials: brass, aluminum, and and caustic and sugar. So in that center core, that's what that is. So
Did I say aluminum too? I believe there was, I should have said aluminum in there too. So plus a couple other things that I put in there. But anyway, that center coil, actually, that's the agitating aspect of the whole thing. And that's going to be the last probably aspect that would actually get hard because it's warm in there. There's caustic, there's sugar, and there's aluminum in that center tube. It might not even ever freeze in the middle. That's what I'm
right. Well, if you
wondering.
got caustic and aluminum, it'll definitely be generating heat even on a micro level as it slowly dissolves and turns into hydrogen and so on.
So if I keep the freezer at like 14 degrees, so we'll see. Maybe it might not freeze. I don't know. Like I said, that's just an ongoing thing. But it was a nice thing to see how the field started. So these are actual physical ways. If we have rings and tubes or whatever people are doing, you really don't get the effect on camera. But if you were at home and you did this, now this actually made me do something different that I didn't have any idea to do to this unit because of what I did by doing that.
Good point. Yeah. So now you have a better visualization of what's going on. Is the point? You can see the fields rather than having to feel the fields, let's say.
Right. Or having that little detector beeping, beep, 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 beep. That's a nice indication. But now actually with our eyes, we can actually see which way the directions of the field are going. And that's what made me change my my thinking from just by that observation alone. It made me change what I think should be done on my larger unit. And I broke it all down again because what is happening here is I have this unit frozen in ice, and this unit is just a beginning version of this unit. This unit here has all the wires and everything connected. This unit is was the first stage of it. So now I know. So I froze this unit in the ice to tell me exactly what's going on. And just by these nano-coated mini spun maggrav coils, it gives me a unified field that starts from the bottom and works its way to the top and shoots everything outbound. So I said to myself, well, that's a great idea because that's going to create an outbound field that I can collect. And that's what made me change my idea on my outrigger field, because I was going to try. I sat for 2 weeks trying to figure out what to do with these things. I thought, well, I'll make this and try to connect that. But this made so much when Lee started that, and then this gave me that answer. So now I know once this unit is mounted between these two coils and it makes a unified field between these two coils, these two coils are not going to be able to click that unified field. And if you think about it, once a mini maggrav is, you've seen them before, they turn and I can have them different directional turning. I can actually create a field, a clockwise or a counterclockwise field. So this side to the opposite side of this unit, now I can create a figure 8 by this unit turning this way, by making a complete unified field this way. These unified fields will collect this way because now you have a unit that's actually going to be able to collect, in a differential, as a, I keep using differential, but that's not the right word. A gradient, yes, yeah. Between the two different coils. Once that field, if you looked at that field, it's a high and a low field. So these two coils are going to be able to have the different gradients. And once you have the CH3 or the CUO, now you have a potential of a difference.
and I'm going to have those inside here too. So the potential difference between just this unit alone is astronomical. And then this one is connected to the opposite side in a figure 8 configuration. So small ring to large small ring to large big ring, which gives you the figure 8. And then on the opposite end, this unit will turn this way. On that side, that unit will turn this way, which would actually make those balls of field created the figure 8. Does that make sense to you? That's the hypothesis in my head.
Well, the main thing is it makes sense to you, and it does make sense. It's a little, it's not complicated really. It's actually quite simple in the way you explain it, but it does make sense. I like the way you have the gradient, and the figure 8 concept is really good. And we'll always know the free plasma is in the middle, and you've got the perfect sort of combination, it seems, there to generate, pick up, create the free plasma and everything else all in one nice structure. So, will it work? Who knows? But
I have absolutely no idea, Rick. But this, through weeks and months, I couldn't touch this we seen it working how many weeks ago? Maybe.
Yeah, we saw it was like a creature come to life with all of its whirling and.
With the shaking and the wobbling, and then
the shaking and the legs were wobbling, and it was doing the funky chicken there. It was pretty cool.
And this is how the technology goes. I had to stop because the input wasn't there, and then I had to learn in 139 about, I think it was 139 or 142, I can't remember, about the central core and what we should have in the central core. And then I made the rubber band central core, and that changed everything. And now with this revelation, this changed the whole thing again. So it's an ongoing creature that needs to be, don't feel like you have to have it rush into having something, or have to have, I had a conversation with John. He said, it's so complicated that, there's so many variances that could go wrong. But if I don't do it, we won't ever know what the variances are. And I don't have any idea what this could or could not do, but at least somehow, some way that my thought process, along with everybody else's, just like I said, B gave me that idea to put that in ice. Now that idea of putting it in ice made me think of a different way that would actually make my unit, I think, work a little bit more efficient, just because of what his input was. And I think with all the input that we keep giving each other, we are going to accomplish this in a relatively quick fashion, more faster than we could have ever done by ourselves. Does that make sense?
Yes, of course. It's the only way to go is to learn and teach at the same time, and everybody else participate. It's a little dicey, and sometimes probably some people get bored or some people get excited and so on, but everyone gets something out of it at some point, and everyone has something to contribute at the same time. So yeah, it's a great plan. I like it.
Yep. One step at a time, right?
Well, that's the thing. That's the way we generally tend to walk or even run. Actually, if you try to do 2 steps at a time, then it's only hopping.
So that's it for me. I don't know. I just, the ice and everything is just like in the forefront right now. The other things are in the ice box. The configurations of how they're coming together. My little other little experiment is starting to. I put some aluminum in that, and I'm getting some readings off of that.
I mean, it's exciting. It's just, it's a hobby that's, it's good. It's good to occupy your mind with something that's creative. Let's be a little more creative. Let's not be so stifled in the mundane of getting up and doing this and that. And if we just use our creative mind a little bit more, we might stumble on something that might be worth something to all of us.
Thank you, Mark. That's good.
Okay. Thank you, Rick.
All right. Alper, I saw your nose in there. Did you have something you wanted to show along with that nose, or?
That was a mistake. I'm very sorry. I was just
Okay.
trying to, change
Okay.
the page on my phone. I'm
Okay.
terribly sorry that was that. But I
Cool.
love to. I'm loving it. Thank you for sharing it. I'm just listening.
Right. Thank you. All right.
Hi, Rick. I'm back.
Okay. Mario, hi.
Typical Thailand. Supposed to be 3:30, but it's not ready till 5:30, so I have to go back. But I have a new reactor array. If you'd like to see it.
Oh, of course. Oh, we just getting a parting shot from Mark of his array here. Is that it, Mark? That's a nice shot. Thank you. Okay, now we can move to Mario. Go ahead, Mario.
Yeah. Let me move my. See, I guess I gotta get my camera going.
Okay.
All right. I don't know if you can see it there. Can you see it?
Yeah, let me get it set up on the old spotlighted video, second screen pinned and spotlighted. All right. Cool.
Nice.
We love rotating things, and you're getting really into this rotating thing structures. That's great, Mario. Okay, take it away and explain what you got there.
Well, okay. Here's the idea. You remember I had the fields from the soul of that insect, right? I have it loaded in another reactor. So I have zinc, CO2, a drop of that which has copper oxide, and my blood and my amino acids. And that's loaded in the central pyramid, which is, if you see this one, that's the top reactor, and those are, I should turn this off for a minute. Those are the 3 base reactors. The way this works.
That'll bite your finger, I was going to say. Yeah. So, yeah, let us see what you have there exactly. Yeah, so it's a pyramid.
Right, but it's really a ball inside a ball inside a ball. Because these 4, this one, that one, that one, and that one, are loaded with the same gases. So they're connected, and they're creating a ball of zinc, copper oxide, soul fields, and all the rest of it. In these, I have copper oxide, so that's another ball. It's not a physical ball, it's a plasma ball. And then these 4 are CH3, and I've got a drop of all of that in these, so these are connected to the copper oxide here and to the hydrogen. And it's extreme alkaline, it's 14, okay? And the idea is I got a ball inside a ball inside a ball. But what I noticed about this is interesting, is that when it's spinning, I'll spin it again. I've got a wobble in this. I'm leaving tonight, so I won't have time to really get it right. But you see the 3 top reactors. There's one at the bottom, one at the bottom, one in the center, and one there. They're evenly spaced, so I have that pin straight through the center, right? So say these are spinning at 400 or 500 RPM. This one on the top is in place doing 400 RPM, but these 3 base reactors, which are connected to it, because they're all CH3, these are traveling at around the circumference of about at least 2 feet. So the velocity of these 3 down here is 10 times. If it's 400 RPM, it's 800 feet a minute that these are spinning. So their overall velocity is increasing the overall spin of the plasma by tenfold, probably. And considering I already have a rotation in the fields just from the gradients, I'm sure this reactor, the way it's set up, is creating a ball inside a ball inside a ball that's creating a spin of 10, 10, 15, 20, who knows how many thousand RPMs.
It's a great idea. That's a good concept there. And also, if you think about it, there's a saying that the center of the wheel never spins, or center of the wheel never turns, actually, or never spins. Right. So when you look at it mathematically, the closer you get to the very center, the slower it goes in speed, right? It's still the same number of arcs per second, but it's the speed is slower and slower and slower, till eventually you reach infinity in terms of the speed slows down to as close to zero to be infinity, or to be zero, basically. So that means that the center of the pin in the very center has actually basically a zero gradient for speed, and that's where the free plasma would exist, right? Because that's the center of the cyclone, that's the black hole, that is the essence at the core of the physicality, and so on. It's all the same thing at that central. It's the implosion bubble, the sonoluminescent bubble. It's where all the energy comes from. It's the voidness of the void. I could go on. But in any case, you got that gradient, and then you've got these ones on the outside. And something about the triangle here, due to the rotation, becomes a cone rather than a faceted triangle. We see it as a cone. We see the other things as tubes almost, rather than spheres that are rotating on the outside part. So it becomes like a series of tubes, a series of maggrav coils. It looks like the maggrav coils is what we're looking at.
Yes, exactly. And it's the crystal tube reactors without any crystal, without any tubes. It's
right.
A ball inside a ball without any balls, you know?
Right.
And when you look at this, like you see the central pyramid there, but then the distance between the three base pyramids here, and there's the top reactor, the number 2 pyramid, that's got a wobble in it, I got to fix. That creates a diamond structure. So this central one, CO2, the second one is copper oxide, but there's a link because I've got a drop of copper oxide in the Gans water of the first pyramid. So now I've got a looping effect because you have a star formation and another one directly below it at equal distance. And the same thing with the third pyramids. You've got these 3 here and that one down there. Oh, I keep doing that. And then these 3 here connected to this one here. So I've got a crystal inside a crystal inside a crystal. And again, no crystals. But it's creating the structure plasmatically. And I'm sure that this, if I can get that wobble out, opens the central core. And the idea is this one.
Well, let me interrupt just for a second. While you mentioned to get the wobble out, it may be that the wobble actually is a secret to produce. See, with a wobble, you have waves being given off because it's an irregular rotation. It's the same idea as the yolk and the egg that was talked about earlier in the rotation, where you have to have that imbalance in order to generate an actual, well, it's a gravity wave or a symbiotic wave that can, a longitudinal wave that can be hooked up to, perhaps. If everything is perfect, then it may not generate that. Although since you have a faceted pyramid, then it's bound to generate a wave anyway because of its structure.
Anyway, yeah.
So you may want to make it balance as much as possible. In any case, I'm just interjecting that there's 2 ways of looking at that imbalance. I've done the same thing with with my imbalanced spheres that you rev them up a bit and they suddenly get into balance at a certain point and so on. Anyway, carry on. Mm-hmm.
Well, okay. No, that's exactly, it's really interesting. When I first started spinning it, it was really wobbling. So I had to put this here because I'm spinning it from the bottom. I don't want a motor in between these. This one's loaded the exact same way, only I've got it acidic, but I can only get it to about a 4 or 5. So it's more gravitational balance. But these two have the same exact gas situations, but all of these have caustic and they're 14 pH. These are about a 4 or 5 pH. So now what I'm trying to do is get a central core started there, free plasma, a central core started there, free plasma. And now, once I have those two free plasmas, they can link up in the center. Then I have a free plasma in the center, not connected to the ganses directly, and I can shut the motors off. That's the idea. So that once I've got that central core open in the center, it's unfortunate I could not get this because I'm spinning it from the bottom, and it was just wobbling so much that I had to put this here and put a pin in it to keep it solid. So it's probably that, interfering with where I want that central core to go. So I'm not sure how to deal with that, but that's the idea. That's the idea, is to get these to open a central core, and then I don't have to spin them at all anymore.
Can I offer a bit of a thought, Mario?
Sure.
Looking at Mark's experiment between the two systems that were in his fridge, the system that had just GANs in it, we didn't see the fields. We didn't see the fields being expressed in the freezing water. We only see those fields expressed when there's nanomaterials involved. I'm wondering if you're going to need to add nanomaterials into these systems in order to actually express the fields.
I know I have at least a little bit of GANs in the water of all of these.
Well, GANs isn't nanomaterials. This is if you look. Oh, you weren't here for Mark's demonstration. He has 2 containers of water in his freezer. One has basically just GANs in little containers in it. One has nanomaterials in with it.
Nanomaterials, you mean copper? What kind of nanomaterials?
Yeah, nanocopper.
Okay.
I mean, the one he's got in there, it's got a little more to it than that. But we see this with the health pens. We see this with another experiment that he did.
Right.
When the nanomaterials are in the system, we see a very, very strong expression in the fields. I think you might have been here in time just to see his last picture.
Yeah.
When he froze the GANs itself, we didn't see that expression of the fields. So what you're describing may be accurate, but it's contained within the GANs itself. It's not getting out past the GANs. It appears that we need to have the nanomaterials in order to express those fields out into the environment.
Oh, I'm wondering if I can connect these with a nano GAN or something like that.
Or a coil between them. Some
Suggest even instead of the blue tube that goes horizontally that is your support, what if you had a nano-coated wire that went across that became with some sort of bearing in the middle that was your support?
I thought about doing that anyway, because I really don't like this plastic being there, and this has not been nano-coated at all.
Otherwise, maybe you could take advantage. What if it was a clear tube and you had some gases in the middle or some other feature there that made that tube? What if you had a hole in the middle of the tube and a GANs ball in the middle to connect the two? You need some sort of medium in between, perhaps. Like just cut a hole in the top and set up a ping pong ball of GANs, a GANs ball there. That could work.
I definitely want to make sure there's nothing that is an open space for a free plasma to to not have any obstruction, to be able to form somewhere in the middle. And that's a
Well,
problem. I'm leaving tonight, so I don't know. I'm gone at least 3 weeks. So
would you
it's gonna
form your, if you were a free plasma, would you tend to form easier in air or in water or in plasma water or GANS water?
That's a really good question.
I
Any
think,
idea?
well, for example, it takes a lot to ionize air, but for water, it's both self-ionizing, which we talked about earlier, and it's fairly easy to ionize it in terms of having a salt solution. All of a sudden, it's full of ions. It's ionized already, basically. So, saltwater solution or a GANS water solution would probably be a nice, friendly environment for a free plasma to want to manifest. In my mind, if I was a free plasma swimming around in a nice salty environment, I think, oh, this is a good place to hang out. A lot better than that air that's, so frivolous. Mr. Keshe has said that water is like a vacuum environment, and to
Sure.
create that, normally to create that plasma that he used to create required a reactor with these vacuum pumps and a sophisticated equipment to get down to that so-called perfect vacuum. We've got a perfect vacuum in our GANS balls in a way, so I think a GANS ball might be an interconnecting medium in between the two forces that are at work here, or some other medium, maybe a vapor. What about put a vaporizer behind it and allow some vapor to come in between the 2 points, so maybe you could see some fields through the vapor, for example.
Yeah, that's an idea. I might be able to take another ball and fill it with all of the ganses of everything, and then empty it out. And then I could put it there, and maybe even run a nano copper wire as a pin to connect both of them, something like that.
Mm-hmm. Yeah.
But I'm gonna have to wait at least 3 weeks to be able to do anything about it now. It's typical of my life. Have to wait.
right at the point of a major breakthrough. Well, this is
Yeah.
good though. This is inspiring, and it's got some very interesting geometry there. It's very close. It's elegant. That's right. Thanks, Guy.
Something really interesting that you brought up. When it was really out of balance, and I've had this almost every single time I make one of these reactors. I started spinning and it was wobbling, and I feel water spraying out on me. So, okay, at least one of them is leaking. I've done this, I don't know how many times. I already know what's going to happen. I shut it off and I try to find which one is leaking, and I touch every one of the balls and there's no water on any of them. And there's no water on the frame. It's as if it's coming out from here or something. And I've had that every time, or not every time. This one didn't, but it was spinning totally more or less balanced, where this one was wobbling around a lot. And I still can't really even find which one it is, but I'm just going to leave it because the field should be in the ball, even if one of them has lost water at least.
Mr. Keshe says it's okay to let them. Sometimes they'll leak a bit and they'll self-seal, or whatever happens, a bit has to come out. But you have to be careful if you got strong caustic there and it squirts into your eye. A drop of caustic in the eye can blind you, actually. So it's very.
Actually, it's really just water. But yeah, I know what you mean. Yeah.
Yeah, it'd be good to have some kind of safety glasses or shield for those of us who are less brave. But I would tend to do the same thing. But you got acid in the top and base in the bottom, so both ways it's not good for eyeballs, really. But still, it's an interesting observation, and I think that maybe it's even just generating the vapors from the water from the air somehow. It's possible.
Yeah, I don't know really what that's
maybe
about.
Maybe you've created a water generator already, and just need to put a pan underneath and collect it.
possible. I thought it was just doing like what the innovation team had, where it was, losing the water, but then the ball's not,
That's
Let-
the
I mean,
more
at first,
rational explanation, but it could be either way. It's
It could be easy to test. I mean, what you allow it to work for a few days and see. Eventually, you're gonna lose these.
he has to leave though, and he has to
yeah,
get back
it's
to it
been
in
running
3
for
weeks.
several
Like,
days, and
Oh,
nothing.
oh,
really?
it has, eh? Okay.
And you didn't see any level differences.
No, I
That's
can't
amazing.
see which ball is leaked. I can't. It looks like there's water in all the balls there.
Yeah.
I can't really tell without
Well,
taking them out, and they kind of.
Yeah.
Yeah,
it's
it's very difficult.
yeah, it's
Well,
kind of
that's
a pain.
interesting.
But yeah. So anyway, okay. Thanks, guys.
Thanks, Mario. Great
Cool.
stuff. Yep. Okay. Let's put the video back on, I guess. And show a couple things, like my roof. And the John, John, did you have something you wanted to show there? There's somebody that had a frozen jar of something to show. Is that you, John, or is that someone else?
That was David.
David. Oh, David IP, that's right. John, did you want to show something while you're on there? Your video's on. John Kane.
Hi, Rick. You all right? Yeah.
Oh, you didn't mean to have it on? Okay.
No, well, I put it on. I put it on just to see if I was working. I'm just trying to get my design based around what was just shown. I don't know. I've been looking at the Pentagon interlocking, similar sort of structure to what Mario had. But I'll just try and get it up because I don't want to show my program.
Okay. You want to do screen share, or do you want to show it on video there?
I'll just show it on video because I'm not set up. I'm going to be moving.
Okay.
Whatever. So I'm going to be.
Okay, we see your
reset up. I'll just
picture
try and
there
get
now.
it. So I'll get it close, and then you can see.
Okay.
Can you see that? Okay.
We see something there. Yeah. We have to. Yeah, we got it. Starting to get it centered there now.
Nice shape.
And it's basically, well, obviously Pentagon prism, but with the
A
dimensions.
little bit higher on the camera. There we go. Thank you.
Not better.
Yeah, that's good.
Yeah, basically, I've taken a Pentagon based on just like a meter, say, on that length, and then you've got the phi ratio across the 2 points there and there, obviously. But the height distance is based on the square root of a hexagon, which is 1.732. And then when you find the 0 point of each prism and lock them at that center, if you've got a reactor on each point.
Up a bit again there.
Sorry.
Thank you. Yeah, it's going down.
I'm on my mobile.
Yeah, okay, great. Yeah, I know it's tricky, but thank you. Go ahead.
Better? You see it fully.
Yeah, that's great. No, thank you.
So the center point of both of those is the 13th position of where I think you may create the plasma, because there'll be 12 reactors and then giving a center point of 13. And it's all based through the 639, the Tesla sort of numerology. So I don't know whether it adds up, but I was thinking also in terms of reactors, maybe having mirrored with lasers into either crystal or the GaNs. I've been using crystals, but I have been using the GaNs obviously because I know like fifth dimensional, superconductive materials. So that's a theory that I've got going with
Yeah,
the Pentagon.
Really
and
like
everything.
really like the image. It seems right somehow. It seems correct, you know. And the analogy with you have 6 and
5.
That's 5. But if I had
Pentagon,
6,
is it a pentagon?
if I had 6 fingers, it'd be 6, and then on the top, and then 6 on the bottom, and so you've got a total of 12, and like you say, 13 would be in the middle. That's the free plasma in the middle is like your 13. Well, it's almost like you have this 6 of one polarity and 6 of another polarity to combine to create that, perhaps. So that's a very nice structure.
Yeah.
Do you have that available as like a 3D file or something that can be propagated? Maybe you can find a way to send that to me, or we can work with it as a 3D,
I'll sort something
twist
on that.
it and turn it and play with it. It's pretty basic, but it's nice to have it pre-made.
I was working with the 13 being like what you were talking about with the music before, the 12 octaves and seven within each octave. But they're talking about 13th octave is what we're missing, or the missing link, you know, in terms of the keystone in the bridge and things like that. I've just been researching, trying to put a lot of other stuff together. That's why I've not concentrated on building this. I've been researching like Michael Tellinger's work in ancient technologies, Greg Brandon, in terms of frequency cymatics. I believe maybe the Egyptians used the actual shape rather than the sound. You know, like if you get a cymatic shape of, say, 3,500 hertz and it gives you a particular pattern, can you not just copy that pattern or change the pattern? Although it isn't actually creating the sound, the actual visual is creating the sound. Do you understand what I mean in that sense? Does that make any sense to anyone?
Well, in the sense that the geometry is what's essential. Is that what you mean? The pyramid shape itself has, because of its shape, already has built-in resonance, built-in power distribution. You could say a field strength according to its structure. And they've determined this on the nano level. You can look at scientific tests on, for example, nano pyramid structures made out of, I think they use zinc or perhaps copper, and they created actual nano pyramids. And then they took the image of the electrical field around it, and you could see these definite points midway up the slope of the I'll have to sort of show my hands as I'm flailing here just a minute. If you had a pyramid like this, say, then midway up the pyramid was one energy structure, and of course at the top of the pyramid was another energy structure. And what they're finding at the top of many of these nano-structured pyramids and other structures, sometimes rods and whatnot, will form a magnetic, rotating magnetic structure, basically, above the pyramid tip. And this is just on the nano level. If you look at that on other larger levels that have been demonstrated on, with various pyramid structures through many years, let alone millennia, that have these. There is a demonstration at the top of the pyramid, for example, I read about the other day, this guy in the 1920s or 30s, they were doing I think it was maybe before that, in the 1800s, actually. And he had it, yeah, that's right. He actually had a Leyden jar and held it at the very peak of the pyramid. and it was charging this Leyden jar enough to create a plasma glow, basically, and shocked this other person with the energy generated from the tip of the pyramid, the Great Pyramid, where he was able to do this test with the before they booted them out of there for showing what they thought was black magic at the time, but it was actually just a scientific experiment, supposedly. Anyway, kind of got diverged there, but yeah, the power of the pyramid is quite interesting that way. It's just a certain acoustic built into the structure, and it's more than acoustic. It's it's more than acoustic in terms of sound waves. It's acoustic in terms of the way the waves propagate and in longitudinal rather than transverse.
Yeah,
fashion.
it would be one of those like John was mentioning, a cymatic figure, almost like a 3D cymatic shape structure. Is that what you meant, John?
Yeah, maybe we got
I mean,
further.
you can use the 2D to give you a frequency, but yeah, the 3D's you know, you can get that through, is it Nazim Harim and
Nassim Aramin.
yeah. But there was also Michael Tellinger, like some of the ancient structures, like Adam's calendar in Zimbabwe in Africa, that kicks out so many gigahertz of energy just on its formation, and all the ancient sites give off a high frequency. So mimicking those structures to give high vibration in terms of technology can we use that then to give us the anti-gravity and the rest. So I've been trying to do a broad range from the spiritual right across to the quantum to get an understanding of it all. So as Mr. Keshe says, you can take it to whatever level, the soul level, and then try and introduce the technology in between. We should be have the ability to do what this technology is doing ourselves. That's where I'm at as well. But yeah, I mean, in terms of the fields, I seem to find the aluminium Celotex board. I've been building like pyramids around my maggrav units and amplifying.
The aluminum Salabrix board. What do you call it?
Celotex. It's like an insulation board, double-sided aluminium foil, dense. But what I'm finding is, I'll just show you a couple of things. My magrav's like 30 meters away, plugged in, and I'll get the the AC currents coming all the way through my house down the wall. I've got like a gauge there, so, and it goes into the kitchen and down the cupboard, so the fields are expanding all the time.
It is amazing how wood can seem to transfer the plasma fields.
Yeah, seems to be. I mean, there's a void under there for the. So, and I'm getting perpetual energy off my kitchen top as well with. I'll just show a quick magnet one. So everywhere where I've got now in the house, I seem to be getting, perpetual energy based on just a maggrav in my garage. So I've tried building. I mean, I admire you guys because you've done so much work, and I've like been on and off, but I've been trying to understand all the aspects to give me the best sort of I don't know, grasp of the technology. But yeah, it's impressive. I'll try and get that file over to you, Rick. And I just finding the 0 point from the engineering, and when I was used to design truck parts, finding natural frequencies of things, and I don't know how the Egyptians managed to levitate.
You used to design, pardon me, you used to design what?
Truck parts. Used to work
Truck
for a
parts.
truck company.
Okay.
Yeah, so
yeah.
did calculations on like natural frequencies,
Right.
cross sections of parts, you know, to design them outside of like a 20 or 40 hertz vibration off the chassis.
Right.
That's if you get in the ether of the matter, then it disintegrates, you know, like Tesla's oscillating motor that nearly brought the building down, finding the frequency. But it's containing that, isn't it? So that's where you guys are, you know, advanced in that sense. But in terms of magnifying it, we're thinking about mirrored double, you know, like a two-way glass. You've got mirror on the inside, so you can see in, putting the sound into it, either through the offset, the vibration, and then lasers into it to try and magnify the power outage. That was another.
Yeah, I always had a dream since I was a kid to have a device that light only goes into and then doesn't come back out. It reflects eternally inside. So then it would keep amplifying and amplifying and amplifying. You'd have this, you know, reflector inside that would continually collect light. And I thought, wow, wouldn't that be really cool? And I like that idea, and that structure seems like it would be appropriate somehow with, and maybe the only way to do it with flat structures, with flat surfaces, let's say. And maybe that's the proper way to do it rather than trying to do it on all angles in a way. But if the surfaces were nano-coated in a proper way on the inside, then you can create little lasers inside. There's actual nano rods in certain materials with a certain process that creates essentially little lasers. It's a laser light that will be given off. The surface absorbs energy and gives it off as a coherent light. And it's always normal to the surface. So any plate or even a sphere, it's always shooting toward the center that way when your lasers are normal to the surface. That's like 90 degrees to the surface, shooting out. So those plates you have in your configuration would all be shooting toward the center, but also even in a sphere, the same nano coating would all be shooting toward the center. So it would, for example, maybe absorb any ambient energy in terms of heat and convert that to laser light, all shooting at the center at the same time. And I figure, whoa, that's got to be a good combination. So maybe something like that might work for you in that creation.
Yes. Yeah.
So if you have it ready for flight by next week's class, that would be great. Are you planning on doing something with that design to actually create it in 3D, or I mean in real life or whatever?
Yeah, we're gonna. I mean, it's gonna be difficult to do that shape, but we're gonna try and just do one prism, which can do it, and try and amplify a magrav within it, or something of that sort.
Yeah, it's definitely a tricky shape to make. I mean, you can make it out of aluminum pieces and weld it together, I suppose, or something. But what would you have then? I'm not sure.
It's tricky on that. That's the actual build-up of that. Yeah, it needs.
Maybe it's something that needs to be done on the nano scale rather than the macro scale in terms of a new kind of crystal, for example, or an actual nano structure that you could create in that shape. And now we have more and more the ability to create custom built nanostructures. That's really what the whole nanotechnology field is about now, and it's getting into the $1 trillion range in terms of its worldwide value right now, because of just how just making things super specialized that way to create a structure that looks like that on the nano scale. And because it's on the nanoscale, suddenly we don't have to do a bunch of stuff to it to make it work, because it's already working, because the geometry and proportions and its reaction to light and heat and everything else is totally different than it would be on the macro scale. So yeah, interesting. There's kids now that create new crystal structures just from playing on the computer to create a 3D structure, and then finding ways to make it with the amino acids and proteins and elements and everything else. It's almost like they have the ability, some of the kids probably have the ability now to go beyond adults in terms of some of the programs are more visual than data driven, so you don't have to have a whole bunch of knowledge about the angles and dangles. You just go for the visual. That looks like it's right. Therefore it must be right. And like your drawing, your 3D drawing there, it looks correct somehow. It has a certain, like Guy, when you saw it, what you went,
This
went
one?
like wow or something. You went whoa.
Yeah, no, it's quite a special shape. Never seen five. Is it a five?
Six.
Or is it six? Six
It's
point.
five. It's a pentagon with
Oh, I thought it was six. It's 5-sided. I thought we were talking
yeah,
about
it's,
2 6-sided.
It's 6-sided prism, but five. It's like a geometric pentagon to a pyramid, effectively. But the height.
So let me get it right. It's 5 points, but 6 sides. Is that what we're saying? Okay.
There's six
draw it
points, but it's hold on. Let me get me. I put a notepad here. Just not very good at drawing.
Right. I'm confused over the 5 and 6 thing there.
Yeah, that's the little detail I got.
It's like.
Well, that's 5-sided. Where does the 6 come in then?
The base is like the sixth, face. The 6 faces, it's a pentagon prism, but the height is based on the square root of 3, which is what a hexagon is. Basically, I did.
Wait a minute. I'm losing you here. You're saying the base has 6 sides?
No, that would be 5, and then this
You've
point.
got 5
the,
vertical
the
and
point
1 flat at the
base
bottom.
would be the 6th one. So it's a cone shape. You see what I mean?
Like
that would be your 6 right here. That would be the 6. See if I understand it well anyway. You're talking about the base point of your cone would be your 6.
Being one side. Yeah, the 6 side.
Yeah, there you go. Yeah.
Okay, right.
But I did reason why I'm talking about it is because I did a shamanic soul journey and visually saw some technology which was similar to what we're looking at here, with a dodecahedron potentially and a spinning quasi-crystal, which quasi-crystals are built up of pentagon, hexagon, and you've got the hexagon is a perfect charge, like the honeycomb of a bee stores charge perfectly, and the pentagon distributes charge perfectly. And like 5-cylinder engines, the most balanced engine that you can get, more balanced than a 6 and more balanced than a 4. It's 5 is the best, and then it's 3, and then it's 6, and so on. I think in terms of balance, when the firing order's going, because of the angle of fire, you get perfect balance through a pentagon. That's why pentagons always stood out to me, so I'm trying to introduce the actual hexagon distribution and the pentagon shape as well. That's why I've come up with the particular shape, because the height of that is the square root of 3, which is 1.732, which when you add them figures up equals 13, and the pentagon to find is square root of 5, which I've got off somewhere. I'll try and find the data, which is 2.236. And I mean, these are just figures, but you add up to 13, and the pi ratio. What else did I do? No, I'll that's what I'm trying to get understanding of, but like I say, it needs testing out. But I just found the 0 point of each of those shapes and interlocked them, so that is the 0 point of the mass. You know, when you find the equilibrium of a component or a part, or you know, you find its balance point. Yeah,
Center of inertia. Mm-hmm.
But yeah, that point, it's weightless, isn't it? That's where you've got the weightlessness of the actual whatever you've got, effectively right in the center.
Okay, thank you, John. That was interesting. Anything else from your end there?
I think so. No, I mean, I've got a reactor going on my RV, which is only little, but I've got it linked in with a maggrav unit, and I've yet to try it, so I've not put it back on the road as yet. But I'm getting fuel reduction on my car. Not a great deal because I run on LPG, so I guess LPG is actually fifth dimensional energy anyhow as a gas, or you know, as you go up the scale.
What is LPG? Sorry, what is LPG?
Liquid petroleum gas. It's the.
You're running your car on LPG?
Yeah, I'm my RV.
Okay.
I've got a big American RV that's converted as well.
Right. Mm-hmm.
For zero emissions, I've always been trying to do the green thing and, you know, look after the planet effectively, and invested in putting as little pollution back into the environment as possible. But
yeah, it sure beats the diesel, and I mean both of them put CO2 out. That doesn't, but the CO2 is what we breathe out too. Is plants love it. You're just supplying something, a plant nutrient for the plants on the side of the road. That's great, but it's the other 200 toxins that are with the diesel and other automotive fuels that are a problem. It's not so much of a problem with propane and natural gas, but still. It's still burning fuels, and there are some byproducts. In spite of it's supposed to be just water vapor and you know, a bit of heat basically. So it's never quite complete combustion. For example, they put mercaptan. They put mercaptan in the propane. When you think about it, as a stinky stuff, so that you smell when there's a leak. And you think, well, I've been thinking recently, well, okay, mercaptan, it's a toxic kind of stuff. They put it in, it's supposed to burn off, I guess. But where does it go? Where does that stinky stuff go? It's stinky for a reason. Our body knows stink. It knows to keep away from stinky stuff. Stinky stuff ends up with bad endings, you know.
Yeah.
So I don't know. Anyway. But yeah, you're way better off with propane or natural gas in terms of fuels. But the new electric trucks and that are coming down the pike, as they say, down the turnpike in this case, will be succeeding. Just get my video on while I'm ranting and raving. Will be succeeding the fuel-based vehicles rather quickly, probably a lot more quickly than we think, because the lawsuits that are going to come in with all this emissions cheating, which has now become so prevalent to virtually every manufacturer. Turns out that in Europe, all the the local manufacturers in England were being protected by the English laws, and they were allowed to pollute because of that, and the local jurisdictions were protecting jobs, so they allowed the pollution to occur. And the same thing in France with its manufacturers, and same thing with Germany. And it's, you name it, all the major automotive and truck manufacturers have been essentially cheating on their emissions exams, and that means a lot more deaths and asthma and everything else for all the people there. And this whole CO2 thing, well, it's, it added to global warming, and it broke the laws, and they'll pay billions and billions and tens and hundreds of billions of dollars in fines. But the thing is, that doesn't even include the people that are actually upset over the situation and are going to have a class action lawsuit for the health effects, which haven't even been touched on yet. So, there's a large percentage of the 5 million people a year who die from the burning of fuels in our vehicles and industrial sources. A lot of them aren't very happy after dying. They're floating around at their, Jesus, I could have lived another 20 years and had more fun. I kind of miss the old planet. And now they're kind of peeved, and the ones before them, the year before that, another 5 million, another 5 million. So there's like tens of millions of souls out there that aren't too happy about a premature ending to their lovely evolution on planet Earth. And besides that, though, there's the hundreds of millions of other people who are wounded by these fire-breathing machines that we drive around as humans, as if we aren't killing enough humans on the planet directly with bombing. What is it? The U.S. is dropping 3 bombs per minute, I think it is, on average, something like that, all over the world in 7 different countries last year. As if that isn't enough to kill enough people, then we have to be killing them through, still, even though knowing, we're still creating vehicles that pollute enough to do this. This is like total chaotic craziness. In order to protect jobs, we're killing people to protect jobs.
Hey Rick, I got something to put in on that.
Okay, that's Peter. Go ahead, Peter.
One of the things is also too, it's not just like the pollution from the vehicles and everything is a contributing factor, but everybody seems to not add into the ultra saturation of the nanometallics from the chemtrails, because from the calculations it shows that from even a year ago there's over 64% more pollution that just sits at about 3.2 feet off the ground from the vehicles. You can actually in Souk here take a carbon monoxide detector and go onto the street on a Souk road during rush hour, and the thing will not shut up. It'll be beeping. And now just imagine if that's in your house, you'd run out the doors. So where are you going to run on the street?
That's
especially
right. That's why I stopped going to a place that I frequented in Souk, and the exhaust fumes are just overwhelming to me, and I couldn't operate my business and the friendships I had there anymore. I had to leave the area immediately after
it
a
is
couple
getting
of
pretty
months.
bad.
So that happens, and all kinds of diseases they've now attributed dementia directly to living close to a busy roads.
Yep.
And turns out 40% of the population of North America lives right beside busy roads. Do we have a high percentage of dementia? Yes. Hello. And now they're also linking Alzheimer's and directly linking asthma. The asthma in kids is being directly linked to the nanoparticles, the nanocarbon tubes specifically that are created in diesel exhaust, gets lodged in the kids' lungs, and they find the same exact nanotube, carbon nanotubes at the site of the asthma inflammation in the kids' lungs. And now it's finally linked directly, and now we have evidence of what's going on that's been pulled over our eyes for a long, long time. And there's going to be massive, massive, massive class action lawsuit over the entire world, several billion people involved, into the many hundreds of trillions of dollars. And this is great because think about it. Think about it, people. This is the best thing that has ever happened. Why? Why? You think it's going to bankrupt everything? No. Don't think about that. What's going to happen is it's going to transfer the enormous wealth that, for example, we just have the statistics. There's 8 people in the world that have the same wealth as half of the entire rest of the world. Huh? And we have in Canada 2 Canadians that have the entire wealth of 1/3 of our population. So this is like a little out of step. So what's going to happen is those who have the wealth involved in the auto industries, which is a good part of the wealth, and in the associated industries and so on that are involved with all that, what's going to happen is due to this massive class action lawsuit, it'll force all of those people who have that massive wealth into the tens or hundreds or quadrillions of dollars, whatever. It's an astronomical figure for any of us that can even think in those realms, and I can. It's going to transfer that wealth to all of the ordinary people who have gotten sick, which is full range of the whole spectrum of society, but especially on the people that live on the wrong side of the tracks. You know, you have this saying, oh, they don't hang out with them, they live on the wrong side. The poor families on the wrong side of the tracks. Well, yeah, they're the poor families because the land's cheaper there. Why is the land cheaper there? It's the wrong side of the tracks because the wind's always blowing downwind onto the wrong side of the tracks. They get all the pollution, all the crap, all the diseases.
Or they had the high grounds, you know.
Or you can live on the high ground, the highlands, the place
That was
that's up
more like-
above.
yeah, it was
you know,
above.
maybe even in a skyscraper, because that's way above all the pollution where the poor people on the streets get. And yeah, from that 3-foot level up to several meters and so on. In any case, I see this as happening because all the manufacturers are getting hit now with they've been proven. You know, Volkswagen just got a $10 billion with a B dollar fine in the U.S. and their top executive was arrested recently, a few days ago, a top marketing executive in the U.S. for basically lying to the U.S. Committing fraud to the U.S. government, and basically he lied and continued to lied about the cheating that Volkswagen was doing and continued to do so to distract them for over a year when they were trying to get hot on the trail of Volkswagen. So they're not too happy with that. They've also arrested 5 others. Not arrested, sorry, they put out warrants for 5 others, but they're in Germany. This guy happened to be on vacation and they nabbed him while he was on vacation in the U.S. So this is what's going to happen to all these higher ups. They won't be able to take vacations, they won't be able to go on trips, they won't be able to go anywhere, do anything. They're nabbed. And this is going to go right up to the highest CEOs of the top companies of the world. And they're going to be stuck because if they travel to the U.S., they're going to get nabbed. If they go to England, they're going to get nabbed because England's not in the EU anymore. And if they go to any other part of the EU, even within the EU, because they all have their separate jurisdictions over some of these laws. and it's going to make travel impossible for them, and it'll make it so they will be forced to pay back all of that trillions and trillions of dollars of money to ordinary folks, people like you and I, who are subjected to these obnoxious fumes on a daily level, especially in the cities where the pollution is really prevalent, which is most of the top cities of the world, especially in China, China, Spain, Mexico City, a few other places that it's really, especially Paris is especially bad. And most of those cities are committed to eliminating all diesel vehicles by the year 2025, if not earlier. That's only 8 years away. That's, you know, very encouraging. So that's poof, all that gone. And all this hope of the oil sands of Canada being used to power all these Chinese vehicles and industries, that's not going to happen. And the thought of it going to the U.S., that's not going to happen. The U.S. is now a net exporter of oil due to all the shale drilling they do, cross drilling and new techniques and so on. They're now for the first time in history, they're a net exporter of oil. They put more oil out than they don't have to buy Middle Eastern oil anymore. They don't have to buy Canadian oil anymore. So we're in a whole different ball game. It turns out that Canada's stuck with a bunch of oil that we can't move. It's too expensive. It costs $80 a barrel to break even in the tar sands. Oil's now at $50 a barrel. So how many barrels do you have to sell in order to break even? Quadrillion, billion? Maybe we break even then.
I don't think.
Well,
How about if we export more to China? Then we'll break even. Yeah. Blah, blah, blah. Yeah,
the solution to Alberta's problem especially is that pipelines, of course, go to the mass stealing of wealth from all the provinces. That's why they go east into the coast here. But the thing is, though, is that if we build more refineries, the fact that one average size refinery provides more jobs than over 60% of the oil field. So add a few of those refineries up.
Why would you want a refinery where there's no use for the material, and plus the refinery expenses are so expensive that you cannot sell your product at the end of it because the oil is dirty, dirty, dirty. And by dirty, I don't mean excessive CO2, which is what they've converted that term dirty from 10, 15, 20 years ago, back when I remember the word dirty came out, and turned it into that supposedly the tar sands oil is dirty oil according to the EU because of its high CO2. It takes more emissions to convert it and so on. No, it's because it is high in what do you call it? Sulfur. It's high sulfur oil. Very hard to refine. None of the refineries can refine it without modifying all their equipment, like Irving Oil had to do recently and so on, to try to get this oil that it's importing and refined. And it's a major multi-million dollar investment to do so, and none of the refineries wanted to do that because it's dirty oil. It is the lead. Remember lead? We got lead out of gasoline because everybody was going crazy and the kids were getting totally stupid in the 60s and so on. Look at the charts. And then they got rid of the lead, and yes, everybody started to improve and so on. We had less birth defects and everything else. And it was a very good thing. Well, now sulfur is what's called the new lead. Sulfur in diesel is toxic. Sulfur dioxides and sulfur oxides and nitrides and everything else are all are what is like the new lead. They call it the new lead. So now people are all toxed out by dirty oil. We don't want to be exporting that to China because they have major problems. They figured that out though. They're no longer they've now banned dirty oil, high sulfur oil, from their major cities, and they're banning it from their whole country in the process of that because they smartened up to that one. So we can't send it to China anymore. China's not going to be able to use it. It is entirely too toxic for their environment. They're more conscious about their environment than we are now in Canada. It's just putting us to shame. It's ridiculous. They're on the high road and the fast road that changes over to electric vehicles and over to a whole different infrastructure in spite of them buying way too many coal and running things on coal still. So they've got modern changes at the same time. They recognize they have to change. Their pollution's so bad recently they've had to keep kids from going to school and shut down factories, allow people to drive every other day rather than every day, and all this kind of thing. It caused massive traffic jams and all kinds of problems. They can't even see to operate properly. It's so bad. And this is in several of the major cities recently have all had major pollution outbreaks, the worst they've ever seen. And this is something that's has to phase out. Humans are killing too many humans this way. This is a faulty fuel issue, and we need to stop subsidizing something that's yeah, I mean, here's the Canadian government predicting 100% cancer rate within two decades here in Canada. I mean, how can they predict that? Well, because they, are heavily invested in the oil and the whole thing that goes with it, and that means, when you start a new oil town somewhere, the first thing you do is you stick a cancer clinic up on, that's one of the first things that goes up is the cancer clinic, because they know that people are going to get cancer. Well, this is not acceptable. We need to have a better plan than 100% cancer rate. We already have over 50%. It's ridiculous as is. Almost all my relatives have died from cancer in the last 5 or 6 years, 7 years. So, yeah, it's time for a change, and that's why I'm sticking with the Keshe Foundation. That's why I like the plan. I like the way things are going. I like the way that there's tests being done with the GANs and GANs water, and many testimonials and scientific results coming in proving beneficial results and protective effects and that kind of thing. So this is all part of the plan, and we need to continue working to essentially offset the effects of some of the negative things that go on in the world. I don't want to dwell on it really anymore, but I'm trying to look at it positively. I see so many positive changes happening as laws are being changed. Executives and these established companies that have been there for decades and are being challenged, and this is the way it should be. We have the new Tesla car company, for example, as a major challenger, and now it's turned out to be the quickest car in the world, 0 to 60 times. The latest one that's modified a bit, in under 2 seconds, 0 to 60 miles an hour. And you can't beat that with any petrol automobile at this time, including the Bentley 16-cylinder or the any of the even most severely tuned drag racers will not make it 0 to 60 miles an hour in 2 seconds. So it's pretty amazing world we live in, where people can go ahead and buy a vehicle like that, and even up to this year or up to next year, were able to plug in and have free power to charge it. And so they pay for no fuel. Wow, that's a good deal. So you lease this thing, and the lease payments are cheaper than a new truck, and you've got a vehicle that requires no gas instead of the same payment as your truck payment every month for gas. And a whole new world opens up. And then turns out you can plug into your home and power your home from your car. That's a pretty good deal. Then you go and charge it up during the day, plug in your home at night. I think that's kind of neat. And that way you get free power from your home too. But this is just an interim step, this whole Tesla car thing. An interim step because we're working toward, the electricity has to come from somewhere, and most people don't have clean sources for that electricity, so it might be a power plant somewhere. We have hydroelectric power in a lot of times in Canada, which is nice, except they sell most of the power to the US apparently, and then overcharge us for power that they buy from somewhere else or something like that. And anyway, in any case, there's a lady complaining recently, yesterday on the news, about paying $1,200 a month for her electric bill in Toronto, Ontario, Canada. $1,200 a month, and that left her $65 every 2 weeks to feed her kids with. So, and she was working at making $40,000 to $50,000 a year, and here she can barely scrape by because of the high power costs and other costs. So we need to have a different solution, of course, and again, that's where the Keshe Foundation is always actively working towards. So this is a great thing that we have solutions, that there will not be a collapse of the whole economic system and a collapse of everything. We're going to see a transfer of the funds from those richest people of the world. They're going to gratefully hand over the money to the people who need it, who are sick and dying, and not even sick and dying, just kind of PO'd about the whole situation. Well, everybody should be granted funds from the people who are the richest just because they've been taking advantage of humans' health by killing them and maiming them, and then offering solutions for the killing and maiming, such as pharmaceuticals and all the rest, all the hospitalization, that's goes with cancer. It's a
cleaner technology too.
The which?
Cleaner technology suddenly, that forces the game, all these guys, to actually now to clean up their act. And that's the greatest thing out of this. I think it's that now everybody knows, and it's going to be really
and they won't be able to just simply, like Volkswagen, they, of course, at the latest car show came out finally with their electric Volkswagen van that looks sort of like the old Volkswagen van, but it's four-wheel drive and electric, and it'll probably be a big seller. But that's, they could have had that 20, 30, 40 years ago. They could have made the original Volkswagens like that, as far as that goes. Instead, they put these smoke-belching things out because they have major investments in the oil and gas industries and so on, and it's all meshes together, and we've learned to endure it because it's jobs. It creates jobs for doctors, jobs for hospitals, jobs for morgues, jobs for everybody who's involved with all the warped and twisted stuff that's involved with all that mess. But humans are starting to wake up and figure out where some of these strings are attached, and now the people involved, because they knew about this many years ago and refused to acknowledge, and instead of helping the humans, they just took advantage of it more, much like the cigarette companies who developed cigarettes that are specifically made with certain additives that become addictive and so on. Right back into, you can trace it back into before the 1900s, around the 1900s, when they started making additives for tobacco and got people totally addicted on it and whatnot. And it's very sick from it because before that they weren't getting cancer. But because it became a major industry, then it created jobs. Well, we can't say no to jobs in spite of them being in the health industry to help people that are sick from the jobs that are created in that industry. But hey, as long as it's jobs. So this is what we have to get away from. We don't need those we need jobs in the health industry. Yes, we should be, most of the jobs in the world will be and should be in the health industry in the next while, helping each other in a meaningful way, not pass as a drug passer of pharmaceuticals and being looked upon by doctors as having not enough drugs in your body or too many organs. So we got to remove some organs and fill you up with some drugs. That'll fix you. Right, they tried to do that to me at least half a dozen times in my life, and I refused each time. I'm still ticking, but sometimes I wonder. But anyway, boy, I got far afield there, didn't I? Rick's ranting, you can call that. I didn't get too upset, though. I can get pretty upset sometimes when I think about the massive desecration of the humans on this planet and forcing us into not liking each other in spite of we're all connected. Hello. Do we really want to bomb each other? Do we really want to fight each other? It comes right down to I doubt it. Anyway.
Rick,
yes, hello. That's Zane. Hi, Zane.
Yeah, brother. Do you know anything about these earthquakes? I mean, like, I know my land is moving, man. Our property. Like last week, I had about 1.5 feet of sand in front of my gate, and I had to like really pull it and pick it up to get it over, And I was thinking that it's about time for me to dig it out. Well, just the other day, I went to just go walk the dogs or whatever. I go to the end and open a gate, and I can actually open it all the way up and then close it beyond the point that I should have been able to.
Which part of the land do you live again, Zane?
Florida.
Florida, okay.
Yeah, and it's like
well, you got some sort of swampy, shifty kind of land there, don't you, in Florida?
Yeah,
and if
yeah,
anything shakes,
it's all
it'll really shake
yes,
things.
Sir. It's like sugar sand.
Yeah. Yeah, I lived next to a bog one time in New Westminster, and every time a semi-truck would drive by on the highway, it would create a wave in the bog, and it would shake the house that you're in. So much that people couldn't have a phonograph player, a record player, because it would skip across the record, and it would make you feel nervous all the time, like you're always shaking, It's very weird. But yeah, I guess it would be sort of like that.
My dog's crazy too. It's like
well, speaking of crazy, there was just an earthquake, speaking of earthquakes, in Italy. Amatrice, Italy's 5.3 that just hit a few minutes ago, apparently.
Wow.
So that's interesting because the earthquakes have been near dead. There's only like 20 a day, and the whole Pacific area went near dead. There's hardly anything there. I've never seen it so dead looking. And but yet we've had major predictions for the west coast of North America, and it keeps avoiding that whole area. And now it was really active in Alaska. Now that's gone dead, and the whole Pacific Rim that's gone totally dead. Indonesia, a whole area that was totally active. Even in Japan, they have a little one there, dead. And I'm waiting for something big to hit, basically, because something doesn't add up here. It should have, the Earthquake Watchers and Dutch Sense in that channel and so on was all predicting a major earthquake by now on the west coast and so on. And there is a bit of action I see there now when I zoom
Always in
there's
California.
3 little ones in California, 3.8 and 3.1 and whatnot. But still, it's not nowhere near what was expected. So I don't know. It's definitely a lot of unusual things happening on the planet. And yeah, it just happens to be, since you mentioned it, the biggest earthquake today, it looks like, just hit in Italy. So we'll see if there's any damage from that.
Quite close to Barrie, no?
I don't know. There's Barrie down there, and it looks like it's about mid Italy, Amatrice. But it's not as far up in. It's sort of between Rome and Pescara, about a little north, forming a triangle north. Anyway, that's your earthquake update there. Yeah, you know, there's lots of predictions, of course, and lots of action happening. So we just have to watch, and in everybody's individual area, you just have to be aware of what your local conditions are and know what to do in case the earthquake does hit and or tsunami, depending on your local conditions. Have to be prepared. Not so easy a job, perhaps, but even just knowing what possibly could happen and having a look around your place and look at all the things that could fall down in here. I'd be picking up things for days. I'd have to use the shovel and shovel all my stuff from the floor into something I could sort them out later, I suppose. No, I do have to do some changes here in terms of
the deck would hold.
The deck is good now, thank goodness there. It's a
Solid.
new deck. But actually this whole building's quite solid. It's got a roof over a roof, so if a tree fell down it would probably protect it. And it's the all the hardware over my sleeping arrangement that could come crashing down in an earthquake. I need to resolve things like that. Everybody should look around if they're in an earthquake zone and look at things that are glass that are stored up on the sides of walls and what windows could possibly break and things like that. Anyway, don't mean to get too far afield there. We're 4 hours into our show here. Any other comments about that, or other comments, or about other things, or other stuff to show, tell?
Anyone follow Dr. Stephen Greer on his disclosure project at all?
Somewhat. I'm not sure what the latest thing is. He's had a disclosure a couple of years ago, and then continues to disclose to private groups at this time, I guess, with his his desert adventures and famous spiritual sites adventures and that kind of thing, I guess. What else? What do you know about that?
Well, he knows of all the suppressed technologies that are already, there. There's over 6,000 technologies, I believe, that have been suppressed, obviously, but the spiritual side I relate to as well. I mean, I'll show you. I've done a Reiki tool with. I'll just pop that on with a torch.
Just a sec. Let me get it highlighted here.
Green laser. LED torch, which I need to get a new battery. It's gone. But I've got this has got. It's a glass tube with peridot and amethyst running in it. It's a silver base, silver top with a quartz crystal. And I'll not blind you, but when it works, I've got a ring, gold ring of my father's on my little finger, and a titanium one there, and when I put it together, I've got a small amethyst. Oh, you can't really see it.
We can't
There's a
see
small-
the device. Thank you. Yeah.
There's a small amethyst crystal that's on the other side of this ring here that's touching the aluminium. I've used some aluminium tape, and my little finger fits in this. But I got this from like a crystal shop, and I picked it up, and I started resonating with it. It was as if it picked me, and basically, you know, I believe with your intention, like Jesus could heal or whatever with his hands, and these Reiki masters and these non-contact healers, the intention's there, and this is just like an amplifying tool to give that sort of effect through, you know. That's my thought in terms of Reiki, because I've been looking into the healing side of, you know, the technology, and
Sure.
giving you the plasma, and these healers that then go, you know, I've heard stories of people on holiday in Bulgaria or wherever, and there's a healer comes on and he'll do some healing on people and massage, and then he'll go to the trees and bushes and get more energy. He must, you know, either get rid of the negative.
Get rid of the negative. I was going to say, yeah, usually you get rid of the negative. Go screaming off in the bushes somewhere. It's, some people I know do when after they do any healing or blessing, then basically it's like go off in nature and go to let it all out, essentially, but in a special way, of course. Yeah. Okay.
To do it, so that's a different side of the technology I'm looking into, and you know, the esoteric type, and yeah, it's interesting.
Okay, well, keep us posted with any current projects you have going there, or cool drawings are acceptable as well. I like the 3D stuff, that's nice. It's always good to have something for people to have a look at. All right, let me get back on there and... Okay, anybody else has something that's for show and tell here today, which is now Wednesday, January 18th, where I am. Probably has been at most of the other parts of the world.
You want to show your little
oh yeah,
contraption
maybe
there?
I'll show it. Something finally came in the mail here, and it's kind of fun to play with. I haven't actually got it set up yet, but I can show what it would look like if it was set up. Which is this this cool little arrangement here. Okay, so what we have that's cool about it, it came as separate pieces. The motor mount here, and the this chuck. The chuck is the really cool piece. It's a nice little chuck. It takes up to, I think, 4 millimeters shaft, and you put it all together. It comes as a kit. You got to put the chuck on the motor. You got to put the motor mount and attach it, and so on. And it's got it's a double terminal motor, two-terminal motor. So I was able to put my Gans ball in it that I had on a shaft that goes into the chuck here, which is kind of nice. I like that. And you can tighten it down. It's got a little chuck key, and it's got a cute little thing there you stick it into and torque it down and whatnot. So that's nice. Got that, and I've also, with the previous parts I had before from model car and aircraft and other parts, I got a board full of pieces here that I still have to solder together some wires and whatnot. But basically, I'm going to put the little motor, and some of these items, most of these items, on a board this size. And this board, once it has the motor on it, you can imagine this motor on this board. Okay. This will fit inside of my I don't know if we can show it back there or not, but in the background there, over right there, what do I mean with it there? That plexiglass box is what I'm trying to point out, which I've shown before many times. Well, this little board will fit right inside the plexiglass box, which is going to be fun because I'll put this inside. It's all radio controlled. The battery's inside. Everything's self-contained. I'll be able to use my remote control to control the RPM of this motor while it's inside of its little protective cage safely on another part of the room. So I can take it up to 10, 15, 20, 25, 30. I hope to get up to 40 or 50,000 RPM with this system. So stay tuned. We'll see how many RPMs the GANS ball can take before exploding. So hopefully I'll have that working by next week's episode here.
Yeah, tell the price, how much you pay.
Well, actually, yeah, it was a really cheap combo. I think it was like $12 or something. You get the motor, nice DC motor. You get the motor mount, which is important because otherwise you have to fabricate something. It's a pain. And you get this really nice little chuck. And the chuck, I figured, is worth the whole price of admission right there because it'll fit on different motors with different adapters and so on. And it resolves that problem of having a precise way to mount a shaft going into your rotating GANS ball. Of course, this can be mounted any which way, and it can be put on a different setup and so on to be able to use three or four GANS balls in a Starship configuration or any kind of way you want to set it up. So it's just it's available. This was, I believe, geez, I have to check it out. I'm not sure where I got this. I think it was from Alibaba. It comes as a no. I believe it was called Banggood. 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 Strange name. I don't question it. And you can look up some of the little motors they have there. I might be able to find a part number or something if somebody's really interested. But they have a number of combinations of motors and chucks and things like that for, I was looking at chucks for lathes originally. Anyway, that's project that's in the works here. It should be, and in the meantime, I can quickly show, I need to get going here and all, but there, as close as we're going to get for today. I've was working with my spinning orb here on the lathe, and roughly it should be safe to just fire up at slow speeds here. It's not plugged in, I guess. Anyway,
yeah,
I got a reeler in here. Guy, throw you a line there. Give it a lifeline. Just leave it down. So there it is, basically, rotating globe. And I was working with it. I'll turn it off so I can talk. I was working with it, and I had a little septaseal on here, the green septaseal, so I could put a needle, a hypodermic needle, through this while it's rotating. And I was sort of working. I was getting bubbles coming through. It was frustrating, and turned out the septaseal was leaking and had actually broken away from its top purchase here and popped right out. It didn't, this glue, this really normally very, very tough
epoxy,
sticky epoxy top of the line stuff didn't even stick to the green septaseal. It didn't adhere to it at all. So stage 2, I'll go back to the Ultra Bond and try some Ultra Bond Permatex and see how that works. It's really tough stuff, general purpose adhesive, but it's got that polyethylene component.
It's like about goop or?
It's similar to goop, but it's thinner. Goop is also very good for sticking to things, but goop can, it doesn't have as much thinness to it. It's kind of almost jelly-like, and sometimes it doesn't stick right into things the way it should, the way you think it would. So I'm gonna, I think that's what I used this stuff on here, and this Septiseal's staying on. So I'll go back to using that one. So it was, I was trying to create the sideways rotating orb like this, and with a bubble in the middle. But I was getting, I was using the hypodermic needle into it. I was able to insert the needle. I got the big hypodermic here. This guy here. And I was able to actually stick it right. I can't do it right now. Well, I can actually, but it will probably leak out through a little bit. I don't know if you can see. Yeah, you can see that actually. You see the needle inside there. Well, I can withdraw and so what I was getting was bubbles in the middle. I had bubbles all the way across, like a tube in the middle, or a series of bubbles. And I was able to use my hypodermic and stick it into these bubbles and just pull the hypodermic back and suck out the bubbles from inside the sphere. But I had to inject liquid, like I've got liquid in this right now. If I inject the liquid, of course it'll squirt out liquid all over me. But if I was to insert the liquid here with that bubble there, then I can insert it and the air comes out instead. It's sort of a similar thing when the thing's rotating. There's a bubble in the middle and you can stick this in and you can either extract the air, or you have to put a bit of water in. You put water in, extract the air, water in, extract the air. And so what I determine is actually a vibration back and forth is the best. So I make a little motor that just vibrates this plunger back and forth a little, which you can't see, vibrates this plunger back and forth a little bit. I'll be able to extract the air much easier out of the center and hopefully just pull that out, and it'll have no air bubble in there. Then I can put a little bit of special hydrogen in here or other gases mixed in and just inject a micro bubble right into that center exactly where I want to place it. And then I have a rotating micro bubble that's able to be possibly imploded and exploded in terms of creating a plasma fusion structure in the center core of this magic sphere. Very much like a crystal ball, isn't it? Maybe we'll find our future in a crystal ball like this. I'm convinced there's some valid research to be done in that realm. And the other thing I did this week was I made a safety shield. Yay! So I can move the safety shield over, and basically that's in the place there. So now when I crank it up, Guy won't get hit by the debris in a direct way. It'll just be indirect stuff.
Okay, so it bounce at least.
Yeah,
bounce on.
There'll be a few bounces before it hits you, so it'll take the edge off.
Thank you.
I'm always thinking safety first with Guy.
Thanks to spare me a bit.
That's why he's got his heavy clothes on. It's not cold in here.
Yeah,
He's
it's
just
padding.
His throat protection is a scarf. That's really handy. That's what I see the Kurds do that in their military uniform. They have a scarf that protect them against bullets.
Oh my goodness.
Yeah, anyway. I go on sometimes. And trivia. But who knows? Maybe it'll be important to some poor soul out there somewhere. Alright, what else? Anything to show, or shall we wrap it up for today? Anything else calling out to be shown out there in the world? Let me see. Oh, pass me your ball there, Guy, so to speak. Yeah, that thing's cool. This is something that Guy would play with last week. I think it's really kind of neat. And so what it is boy, it looks really cool, doesn't it, when it's up close. Almost has that double, you know, almost like we saw in the field structure of the water that was freezing earlier. In any case,
Could be nano coated.
yeah, it could easily be nano coated. Pass me the roll there. This is what it came from. This stuff here, which I got at what do you call it? Oh, that woodworking place. Name escapes me right now. Anyway, they use it for protecting your plants against slugs. You can lay this on the ground and the slugs don't like it. They don't like copper. Interesting, eh? And they don't like the harshness as well as this. So it's a slug and other bug deterrent. And I think it was about $20 or something for this. It's actually quite a long roll of this stuff. And it's very interesting. I'm thinking of nano coating the entire thing and creating kind of a reactor where the center core of this has got to be the darkest place in the universe, because it would be totally covered by blackness of the black nano coating, many multiple layers. If you're thinking about if you were in the middle of that, it couldn't get any darker, I think. So what a place for a sensor of some sort. You know, maybe a gravitational wave sensor would like to be in a dark protected place like that the gravity waves get through, but there's no radio waves. This is like probably 1,000 or say 5,000 Faraday cages built into one, basically. It's like layer upon layer upon layer of insulation against all the interference.
Maybe it would be better if you do it in the ball, maybe, instead of having those holes in the middle.
Well, possibly, but I like it this way because it's not a messy ball to start with, and you can stick a test tube right down the middle where I could put my sensor in and so on.
Yeah.
But yeah, it could be a ball. It could be like wrapped around this multiple layers. Well, we did something similar with tinfoil on a flask. I think you did most of that, actually. Remember that?
Oh yeah.
Tinfoil
Many layers. Yeah.
Thousands of layers, probably. But this is interesting in terms of what it is if this was a nano-coated or even not, it's essentially like a Faraday cage. It's a layering of charge on the outside of the sphere. And if you had some action going on the inside of the sphere, namely some fusion reaction or some other fields that were generated, possibly this mesh could pick up the fields. If it's nano-coated especially, that would be lend toward picking up the plasmatic fields, and you just have some kind of way to pick up on this, like plasmatic leads going off to your plasmatic capacitors, perhaps, to save the charge. Or maybe it could act as a plasmatic capacitor. I don't know. I just looked at it and went, whoa, that's really cool, Guy. So that's what happens in the background here. Well, I think you did that in the Knowledge Seekers workshop, wasn't it? Or was it in the plasma group last week?
I don't know. That came to me. I just don't remember seeing it.
Yeah. Well, anyway. Okie dokie. I think that's about it from this end for now. Anybody else with anything to see or say?
Sorry.
Thank you, Guy. That's a good accent there. I guess that's going once. Any more sneezes? Alright, well, let's wrap it up for today. It's been over 2 hours 15 minutes or something, or 4 hours 15 minutes. So I've covered a few things and a half here, and as usual, it's a lot of fun. thank you everybody for participating and listening in and generally being part of this madness. I mean this fun. It's all and everything. It's everything you could always wish for in this this plasma teaching in a way. Anything you can imagine is can be found here because it's so essential in essence, not in well, it's essential in many ways. Essential to the planet now too, I think, this whole teaching. Anyway, I won't carry on anymore. Let's bid adieu. I'm going to shut down the live stream.
All right, bye everyone.
Thank you, Rick. Thank you.
Thank you too. All right.
Thank you, Rick.
Thanks, Rick.
That was John,
Thanks, guys.
Doug McDonald, I think. Okay, thanks, Doug. Thanks for your comments too. I didn't read them here. All right. Okay, good. Okay, live stream going.